Testing.
Pretty woman walking down the street, pretty woman.
Okay, so welcome everybody. Welcome to the fourth John McCarthy AI Summer School. My name is Liam Cronin. I'm the CEO of the RDI Hub. And just before I say a few introductory words, a couple of just kind of health and safety issues, just in case anything happens or whatever. So if anybody needs the toilets, they're on the left-hand side. I feel like I'm the guy in the airplane here now for a second. And then there's obviously toilets out the front as well. And again, if God forbid there's an emergency, we have to leave because of any fire or anything like that. The emergency exit's out to the left there, and we have a assembly point 4 outside or whatever. Okay. If anything over the next 2 days you need any help, please come and talk to me or talk to my 3 colleagues at the back there that are supporting the event. So you have Kerry McConnell, who's waving there at the moment. Alongside Kerry is Fionnuala O'Callaghan, and then in the corner is Gerard O'Sullivan as well. And the 3 guys have been doing amazing work putting together the John McCarthy AI Summer School. So as I said, this is our 4th John McCarthy AI Summer School. You might have seen as you were kind of coming into the building, we dedicated this building to John McCarthy. So John McCarthy, is probably a lot of you guys know, his father was actually born 5 miles away from here out in Cremon. He's kind of seen as the founding figure of artificial intelligence, which we're going to be discussing a lot over the next 2 days. And he invented the kind of Lisp programming language back in 1950. And I suppose the reason we have this John McCarthy Summer School always at the start of September is his birthday was the 4th of September. So it was a Monday. So we kind of try and link it in around the same time as his birthday each year and stuff like that. Okay. And as I said, we kicked this off 4 years ago. When we did it 4 years ago, our whole topic was around AI for sustainable societies. We followed it up the year after because we were in the middle of COVID around how artificial intelligence is supporting wellness. And then last year we did it around artificial intelligence supporting tourism. So it's been a really good sessions over the last couple of years. And now we're back to looking at AI for sustainability this year. And it's great as well to have some of the speakers we had 3 years ago back talking again. So like Professor Vinicala is going to be talking. He was talking 3 years ago. So it'll be interesting to see how the research has kind of moved on. Our local professor, Professor Joseph Walsh, would have spoken 3 years ago. He's going to be talking later today as well. So it'll be interesting to see how the research has kind of moved on over the last 3 years around artificial intelligence and sustainability. I suppose, look, this event would not be possible without kind of the support of our sponsors and our stakeholders. So I want to just kind of quickly call out the key stakeholders we have supporting the summer school. So Microsoft, Dr. Kevin Marshall, and now Dr. Russell Kane have been supporting the AI Summer School from the very, very start. So I want to thank Microsoft. The Adapt Research Centre, Declan McKibben, Olivia Walters, based in Trinity College Dublin, have been key supporters. Munster Technological University locally, Breda O'Dwyer, Joseph Walsh, Professor Joseph Walsh. And then we also have had AA Ireland with Mark and Tangent with Ken Finnegan supporting it. And this year, I suppose we have 3 new partners that have come on board with us. So we have the 2 SkillNets, the IT Cork SkillNet and Kerry SkillNet. And who you'll be meeting tomorrow is the Sustainability 2050 Accelerator team out of Dublin. So they're doing a lot of work around supporting sustainability, and they're actually going to have one of the startups who's on the program will actually be here in person tomorrow, which is really, really good. So look, you're not here to hear from me. I mean, I'm not an expert in AI or on sustainability, but what I do know is what a change the last 12 months has made. Like, I mean, when we talked about artificial intelligence 12 months ago, you know, ChatGPT wasn't there. And like when I go home now and I try to explain what my job is to my wife and my kids, they understand it. They can tell me that I should be using ChatGPT. So that's good. You know, it's democratized, I suppose, AI, and it's a lot more out there in the public domain. And then look, sustainability we hear every single day, you know, whether it's the climate crisis, you know, why is it 27 degrees in Killarney and that's September? Like we might find that out over the next couple of days and stuff like that. But I think it's a fantastic topic to look at over the next couple of days. So look, without further ado, and I have to put my glasses on, sign of old age. I'm going to actually like to welcome our first speaker, and our first speaker today is Colleen Josephson. She's an assistant professor at the University of California, and she's going to talk about sustainability, agriculture, and technology, sensing our path to a greener future. Technology like artificial intelligence has the potential to address some of our generation's biggest challenges, but the advances that they have led to today's enormous leaps in progress often have an underlying environmental impact. Colleen's talk will explore the cost of today's technologies and how we can innovate to have both sustainable AI and AI for sustainability. I love that line, how we can innovate to have both sustainable AI and AI for sustainability. So fantastic to have you online, Colleen. I know you're up at an unearthly hour there to join us this morning. I'm not even sure what time it is. Is it 6 a.m. or whatever? So I really, really appreciate you joining us. And we're really looking forward to your talk over the next 20 minutes. So I'll hand over to you now, Colleen, if that's okay.
Thank you. Thank you very much, Liam. I guess give a thumbs up if you can hear me over there. Great. So good afternoon to those of you tuning in from Ireland, and good morning to anyone who's over in the US like I am. It is currently about 5 in the morning. So I'm excited to be here today talking about the growing intersection of sustainability, agriculture, and technology. My background is in wireless communications and sensing with a focus on technologies to enable sustainable practices. For the past few years, I've been focusing on applications in the agricultural space. Though I am not directly a researcher in the field of artificial intelligence, my group and I have used AI techniques to process the data that we collect. And while I was a research scientist at VMware, my work there touched the kinds of large compute systems that enable us to train today's large models. So as I'm sure we're all aware, there's a lot of hype around AI and sustainability. Technologies like artificial intelligence have great potential to address very large challenges, but the advances that have led to today's enormous leaps in progress have often had an underlying environmental impact. So today I'll be exploring the cost of today's tech and how we can innovate to have both sustainable AI and AI for sustainability. Here we go. So to kick things off with a brief discussion of what brings us all here. So most of us have experienced firsthand the impact of increased extreme weather. So in 2020, the entire UC Santa Cruz campus had to evacuate due to the CZU Lightning Complex fire, which is pictured here. Sadly, this is not abnormal anymore. Across the Western US and other parts of the world, events like droughts and extreme wildfires have grown more and more common and impacted the health of people across vast regions. The IPCC, a UN-organized consortium of more than 14,000 scientists across the globe, has been releasing reports that strongly link climate change to human actions. They also show that greenhouse gas emissions continue to rise, despite the fact that almost every country in the world pledged in 2015 to limit warming to 1.5 degrees C. If we exceed that, we'll see significantly more damage. So plants and insects, which are vital for the pollination of crops, are likely to lose half of their habitat at 2C. Corals would be 99% lost. Sea level rise would affect millions more people. Recent studies suggest that we are on pace to exceed this 1.5 degree benchmark by the 2030s. And according to one report by the World Meteorological Organization, they found that there's a 66% chance that we'll exceed it in the next 5 years. So in short, the current pace of action is not enough. The silver lining is that there's still hope. We can avert the worst if we act swiftly. And though the increasingly likely consequences of exceeding this 1.5 degree mark are dire, I keep myself going by reminding myself that every improvement helps. If we reach the 1.5 degree benchmark, we can still avoid 2 degrees. We can investigate carbon sequestration techniques to pull levels back down below 1.5 as quickly as possible. So after that sobering slide, let's talk about action. What can we do about this? So I'm going to go out on a limb and assume that part of the reason that you're all tuned in is that each and every one of us wants to do our part to avert the worst. And as an audience of highly trained engineers and scientists, we are compelled to go beyond individual actions like switching to an EV. We're also driven to dedicate our careers towards tackling this challenge. So this brings me to the two types of action that the AI community can take: sustainable AI and AI for sustainability. Work towards sustainable AI seeks to reduce the carbon footprint that it takes to train and deploy models. There's increasing awareness that training models can consume significant resources. So, for example, check out this delightfully illustrative chart from the recent 2023 AI Index Annual Report. It shows that the process of training GPT-3 was estimated to emit about 100 times more carbon than the average human does in an entire year. These numbers are not small, and these trends should be carefully monitored. While I was at VMware, I chaired a working group dedicated to studying sustainability in the wireless industry. We tended to look at the overall information and communication technology, or ICT industry. Projections show that the emissions of the industry are expected to grow 400% or more in the next 20 years if we don't take substantial action. This means that there's a real chance that the already large carbon footprint of model training could grow substantially. When you pair that with the fact that the number of models being trained is likely to grow many-fold, this is going to add up to significant negative environmental impact. Also, sustainable AI should be efficient with the resources. So that all means that sustainable AI should be efficient with the resources needed to train and deploy our models. We also need to think about the net costs and benefits of AI solutions. So a few years ago, I was interviewed by a reporter wanting to write about technology companies doing work in sustainability. And I was asked a question about how AI helps sustainability. And I had a long, detailed answer about how there's lots of exciting work in sustainability, but we need to be careful to think about the cost of training the models and making sure that the carbon savings enabled by that model outweigh the cost of the training, deploying, and maintaining that model. It was like a 5-minute answer with examples and everything. And when the article finally came out, I was not too thrilled to see that my careful, nuanced answer was condensed to say, Colleen Josephson, expert in green cloud computing, says artificial intelligence can help companies make smarter, more sustainable decisions. And that was it. None of my careful cautions or caveats made the cut. So I think the lessons here are: one, be wary of reporters, and two, seek captive audiences like this one, where I finally get to set the record straight. So before doing a deeper dive into techniques for more sustainable AI, what about the other half of the dichotomy? What is AI for sustainability? Now, broadly speaking, I define AI for sustainability as using AI to help with predicting climate impacts as well as reducing them. This half is what people tend to get really excited about, and rightfully so. There's some really exciting work going on. So, all the way from using computer vision techniques to automatically identify potential poachers in Serengeti National Park, to improved ways of modeling our oceans and other environmental systems. There's a myriad of ways to apply AI with sustainability-related end goals in mind. So, detecting and preventing unwanted conditions like the aforementioned poachers, crop disease, energy system malfunction, and then predicting behavior of some of the world's largest and most complex systems so that we can make more informed decisions, like where to build climate-resilient homes to safely house our growing population. So, for the remainder of this talk, I'll dive a little deeper into these two halves of the same coin, giving some concrete examples from my own work as well as the work of others. First, sustainable AI. I've talked a lot about carbon so far, but an important thing that we need to keep in mind is that sustainability is not just about carbon. We also have to consider things like water use, land use, and recycling. When looking at water use, collectively, data centers are among the top 10 water-consuming industrial or commercial industries in the globe. The reason they need this water is primarily for cooling. In the US, at least, one unfortunate thing is that data centers are often located in exactly the places with the least water to spare. Building a huge data center in the middle of Arizona or Utah seems like a great idea until you think about all the water that you need to operate that data center. There's also land use considerations. Removing trees to build reduces carbon sequestration capacity, and many construction materials, such as cement, have a high carbon footprint. And then there is the equipment that goes into the data centers. Recycling is an important factor. Right about now, only 17 to 20% of e-waste, such as obsolete phones, computers, and servers, is recycled. And for every 1 million cell phones that are recycled, there are tons of pounds of copper, silver, gold, and materials like palladium that can be recovered. And the better we can recover these resources, the less destructive mining we need to do for raw resources. In 2022, my colleagues at VMware and I came up with a paradigm to organize the challenges in sustainable computing. We called it the 4 pillars of sustainable computing. The first pillar is using renewable energy. The second is using resources more efficiently. The third is reducing embodied carbon. And the fourth pillar is addressing institutional barriers. I'll go over these in a little more detail. So, not all energy is made equal. We can't control when the sun shines or the wind blows, but human patterns of energy consumption tend to be fairly predictable. We use more power when it's hot out, for example, to run air conditioning. To ensure that supply meets demand, utilities operators typically provide energy from a mix of power sources. They leverage renewable energy when possible and make up for deficits using fossil fuels like gas and coal. This means that the energy available to us does have a carbon intensity that varies across time. This chart shows an example of what the fluctuating carbon intensities in grids across the US look like. So yellow is California, red is the Southwest, and green is the Midwest. So we see that California often has the lowest emissions, but the Midwest also has periods where the green bar disappears. This indicates periods of zero emissions. So during that time, their grid is 100% renewable. Ideally, we'd like to see all of our electricity be 100% renewable, and we're working towards that. But to maintain the computing workloads that we're used to, we need to learn to work with the environment and be creative in the meantime. An example of some of the work in this area is carbon-aware data center workload management. So the idea is simple. You have a data center computing workload chase renewable energy by adjusting where the workload happens or when it happens, or both. So for example, a workload initiated in the Midwest might be moved to the East Coast or West Coast to take advantage of renewable wind energy, making those power grids have a lower carbon intensity at that time. Or a time-insensitive AI or ML training workload might be deferred in time until there's an influx of extra renewable energy that lets you do those computations for essentially zero carbon. The idea behind this work is pretty intuitive, but as always, the devil is in the detail. Moving workloads incurs migration costs. So the system and algorithms behind this will need to, again, make sure the benefits outweigh the costs, and that the baseline performance targets like latency and throughput can still be met. Our preliminary results on this problem were published in this year's Hot Carbon Workshop. Workload migration was prototyped with actual VMware load balancer software, and we found that our approach reduces CO2 equivalent emissions by 21% while maintaining comparable latency. So pillar number 2, using resources more efficiently. Although transitioning to renewable energy is the highest priority, we still have room for progress in using energy more efficiently. We've grown used to the luxury of fast, affordable compute, and seldom do we stop to reflect that our phones are orders of magnitude more powerful than the computer that first landed mankind on the moon. And there's going to be ways to save power across the entire industry. So for example, if an algorithm is revised to be just 10% more efficient, if that algorithm is used by millions or billions of people or devices, this impact adds up. My own research background comes from the low power domain, where we literally reuse wireless signals emitted from other devices and piggyback off of them to communicate for nearly zero power. These low power techniques, which are common in the embedded systems community due to sheer necessity, beg the question, what can the large systems community learn from the tools and paradigms that embedded experts have been honing for decades? Pillar 3, reducing embodied carbon. Embodied carbon is the carbon that goes into the design, manufacture, and transportation of a device before it arrives in your hands. So this encompasses things like the often carbon-intensive chip manufacturing processes needed to manufacture a GPU or other accelerators, as well as the fossil fuels used to transport materials and components around the world. The way to reduce embodied carbon, simply put, is to make less stuff. How do we do that and maintain our standard of living? By transitioning to something called a circular economy. A circular economy is an economic system that's regenerative. Resource input, waste emissions, and energy leakage are minimized. This can be achieved through techniques like refurbishing and recycling, making our goods easier to maintain and repair, and designing for inherent longevity. The current economic model is linear and based on the take, make, waste, dispose model. It creates a considerable amount of waste and pollution in favor of speed and affordability. By transitioning our electronics manufacturing and use patterns to a more circular approach, we'll greatly reduce the amount of waste produced and decrease the amount of disruptive raw materials mining we need to do. The primary challenges here are that A, the majority of our electronics are not currently designed to be recyclable, and B, recycling technology is also not yet advanced enough to make circular approaches more cost-effective than simply disposing used materials and sourcing new ones. One really cool project in this area is junkyard data centers. This is spearheaded by some of my friends and collaborators at UC San Diego. Smartphones are a great example of devices that have a high embodied carbon footprint. They're engineered to be power efficient to save battery life. So as a result, it takes a lot of charging and recharging for them to accumulate much of a use phase carbon footprint. However, keep in mind the typical smartphone lifetime. 1.5 billion smartphones are sold annually, and most of them are decommissioned less than 2 years later. And most of these unwanted smartphones are neither discarded or recycled, but they end up languishing in junk drawers or storage units. The insight behind this work is seeing that these discarded devices actually represent substantial wasted potential. Modern smartphones, remember, have more computing power than the computer that took us to the moon. They have increasingly high performance and energy efficient processors. They have extensive networking capabilities and a built-in reliable power supply. The researchers aim to grow sustainably computing capacity by extending device lifetimes. In their recent ASPLOS paper, they showed that the capabilities of even decade-old smartphones are within those demanded by modern cloud microservices. And they found that for specific workloads, clusters of repurposed phones are cheaper and more effective and more carbon efficient than traditional servers. So, more broadly speaking, tackling the embodied carbon footprint of computing is a really challenging multidisciplinary problem, and I hope to see more people in the community exploring this in the coming years. Finally, addressing institutional barriers. Technology tools and information are necessary, but not sufficient for us to achieve sustainable AI. Even though we have the means, taking action might be impeded when existing policies, processes, and incentives from our institutions don't align with our goals. One of my favorite examples of this is the entry policy for the beach in my hometown. I grew up in coastal New England, and the local residents can visit the beach for free by attaching a sticker on the windshield of their vehicle that serves as proof of residency. However, if I wanted to ride my bike to that beach, the entry gate requires me to pay a $2 walk-in fee, regardless of my residency. So this policy obviously incentivizes residents to drive their car rather than bike, which has irked me for ages, especially since the beach is run by a conservation group. So looking inwards to our own community, what might our own institutional barriers look like? Do we reward progress in this area or consider it to be incremental? Can people find research funding and share their work with a strong research community? So events like this are a big help. And as an aside, I also suggest you check out Hot Carbon, the ACM workshop on sustainable computer systems. That's where 2 of the works that I talk about here were published, and it's a great event. Another big one is the lack of awareness and/or education. And I don't know if I can see anyone in the audience. This is where I usually like to ask how many people have ever had in their education exposure to the environmental impact of their field. So I guess raise your hand if you ever were taught about the environmental impact of computing in your undergraduate studies. So I'm seeing none, and this is pretty typical. In my own experience at UC Santa Cruz, I've primarily taught so far juniors and seniors. On Earth Day, I do a special lecture going over the environmental impact of what they study. And at the end, I always ask this same question. How many people have learned about it before or were hearing about it for the first time? And so far, almost everybody in the audience has been hearing about it for the first time. So simply put, our most fundamental computing curriculums are not teaching these concepts, which is a major barrier. There's various ways to address the different types of institutional barriers, but I want to quickly highlight one practice that I've started doing in my class on ag tech, or agriculture technology. So the format of the course is primarily centered around fundamental and hot off the presses research papers that the students all read in the broad field of ag tech. We cover things like soil moisture sensing, autonomous tractors, hyperspectral imaging, and more. And the thing that I think is special is that we analyze each paper through multiple lenses: reviewer, funder, and ethicist. The reviewer role has students act like a peer reviewer and focus on the technical strengths and weaknesses of the paper. The funder role asks students to consider whether or not this line of work would be a good fit for startup funding or additional research grants. And the ethicist role asks students to consider the potential ethical concerns of the paper, such as privacy, human rights, sustainability, and more. Do the authors acknowledge the existence of these concerns and address them in any way? For many students, even though these are advanced undergraduates and graduate students, this is their first time looking at the bigger picture of where technology sits in our society and our unfortunate tendency to view our own work through rose-colored glasses. So those were the 4 pillars of sustainable AI. What about the other half? AI for sustainability. There's a lot of examples of how to use AI to enable more sustainable practices, and looking at the great agenda that you all have lined up for the next couple of days, you'll be hearing about a lot of different things. In this portion, I'll be sticking to what I know best and focusing primarily on my own experiences working towards more sustainable agriculture. Occasionally, I get asked how I got into agriculture work. My PhD was in the electrical engineering department at Stanford, and I was one of the only people there in EE or CS doing work in this area. So much so that one time I was sitting in a common area and a younger student leaned over and asked what I was working on. Dirt, I replied cheerfully. And the younger student paused and looked confused, and then asked me if DIRT was an acronym for something. Nope, I am working with real live dirt. And it started with an internship. Like many, I went through a mid-PhD crisis in my second year, where I was finding it difficult to motivate myself to put in the cycles to revise a paper rejection, and wondering just who cared about my current area of work and if it would ever have any impact. I was witnessing a lot of my colleagues do work that got swooped up and utilized to better serve ads to people, and that was not the kind of work I wanted to do. No offense intended to anyone who makes their living off of that. It was just not what was for me. So I decided that a change of pace might be a good idea. And one of my lab mates introduced me to Ranveer Chandra at Microsoft Research, who was recruiting interns for a project called FarmBeats. He was interested in the idea of using low-power wireless signals as an efficient way to sense soil moisture. So as I mentioned, I grew up in a small town in New England. When I moved to California in 2014, one of the things that excited me the most was my newfound ability to grow citrus, and I started growing a salsa garden. So I was intrigued by this opportunity to merge the things that I was interested in, growing food and wireless communication, and the rest was history. So let me tell you a little bit about DIRT. Sensing the world around us is an important prerequisite for many types of artificial intelligence. In my work, I focused on soil moisture sensing first. So it might surprise you to hear that most of the fresh water in the world goes not towards household consumption like showering or appliances, but instead to agriculture. Agriculture accounts for 70% of our freshwater consumption globally, and this always makes a strategic water break. The good news is agricultural water consumption doesn't need to be this high. Decades of studies have shown that using soil moisture sensors can reduce water consumption by 20 to 50% while maintaining or even improving crop yields. But despite these facts, fewer than 10% of US farms use them. So to explain this, let's examine, there we go, there's the statistic. So let's examine what a typical agricultural sensor network looks like. It's a distributed model that involves burying sophisticated and often expensive sensors and then communicating the data upstream to a centralized location like a farmhouse. The power, harvesting, and communication modules add to the cost, and then you have wires and posts that can interfere with farming equipment. In fact, many farms actually need to completely remove and reinstall these traditional sensing systems every year. In essence, farmers are being asked to deploy their own power and communication infrastructure. So that's a high ask, and many of them find it too costly and labor-intensive and difficult to do that, so they don't adopt these sensors. This approach isn't the only way, though. In contrast, the remote sensing community uses a more centralized model. This involves measuring surface reflections with a mobile radar attached to a satellite, plane, or vehicle, so it's completely wireless. The disadvantage with remote approaches compared to a traditional sensor network is decreased accuracy and potentially decreased measurement depths and measurement resolution, especially for satellites. A note on satellites is that we're seeing an increased number nowadays, and there's greatly improved image quality and resolution. But I'll remind us of the earlier half of the talk. We have to consider whether the benefits outweigh the costs. Launching satellites into space takes fuel combustion. One launch emits about the same amount of carbon it took to train GPT-3. And it's unlikely that we'll see alternative methods of launching in the near future. So launching will emit carbon. So as an aside, I was at an event on rural and agricultural computing a few weeks ago, and there was a panel on space-based communications, and it had speakers from the likes of Starlink and Hughes. And I pointed out this carbon footprint of a launch and asked what these companies were doing to look into more sustainably growing non-terrestrial networks. And you could hear a pin drop in that room. So people are very much taking the build it first, think about the consequences later approach in all areas of technology. Now, this doesn't mean that we should not launch satellites, but rather we should think more about these questions and be prepared to address the questions of what is the end-to-end cost benefit of launching this satellite into space, and if it's not where we want it to be, what are we doing to get it there? Anyways, taking inspiration from both communities, we came up with a hybrid model that gave us a completely wireless system without necessarily sacrificing accuracy or depth. It involves pairing inexpensive underground tags with a centralized reader that acts as a mobile edge device. So the details of this work in particular are in our 2021 ACM Compass paper. I'm not going to go over them in this talk in great detail due to time constraints. And instead, I'll move on to a more relevant sub-problem. How do we power these tags? One funky solution we've been exploring is harvesting energy from the soil itself. Dirt batteries, more formally known as soil microbial fuel cells, leverage the behavior of a specific type of naturally occurring bacteria in the soil known as exoelectrogens. These microbes produce a spare external electron as a byproduct of their normal respiration activities, which is where the name exoelectrogen comes from. If you place an electron acceptor in the soil, in this case the anode, and place a load between that and the cathode, you can harvest energy, fairly minuscule amounts of energy, on the order of microwatts, but electronics has progressed enough such that nowadays that's actually enough power to compute low power workloads, like the underground tags that we made for sensing soil moisture. Though environmental engineers and microbial ecologists have been studying soil microbial fuel cells for years, it's been pretty much limited to the lab. We are, to my knowledge, the first group of people to deploy soil microbial fuel cells in a real outdoor setting and collect data. This is early data from one of our deployment sites. And you'll note that one of the interesting aspects is that the microbes actually react to conditions like water content, nutrient levels, and temperature, so that the power output is time varying. And that begs the question, so can we leverage some of these predictable behaviors, like the diurnal fluctuations caused by sunrise and sunset heating the soil, to more efficiently predict and use power? So the first step to doing that, which we've been exploring, is trying to predict power output based off of the environmental conditions. We've had some early success using AI techniques to predict power output from the temperature, soil moisture, and electrical conductivity measurements. But more work is needed to see how well these results generalize across soil types and climates. And that brings me to the S word, scaling. The scale of a typical farm is a huge challenge. Obtaining high-quality datasets is a key factor limiting more widespread adoption of AI techniques in agriculture. For example, deep convolutional neural networks can automate the analysis of UAV imagery, but only if provided with enough annotated data to recognize patterns that us humans recognize naturally. Generating this high-quality data is currently time-consuming, labor-intensive, and expensive. We're working on 2 projects that seek to ease the barriers to obtaining high-quality agricultural training data. The first project, focusing on in-ground sensing, is an all-in-one hardware platform that's optimized for monitoring power output of the soil microbial fuel cells, but it's also capable of collecting data from traditional sensors that measure things like soil moisture, temperature, and electrical conductivity. Our long-term vision is that we'll create affordable sensor deployment kits that we can send to anyone who's interested. The PCB board, which is equipped with both Wi-Fi and LoRa radios, will be by default programmed to transmit sensor data to our database. So eventually we seek to create a global network of citizen scientists collecting data from their local environment, gradually creating a high-quality international soil sensing data set. As part of this broader project, we're creating real-time monitoring and visualization tools, which we're currently using with some of the soil microbial fuel cell data collected at our local university farm. The second project focuses on UAV dataset aggregation. So a few slides ago, you might recall that I introduced this idea of mobile data readers, and there was a lovely image of a drone on the page. However, collecting data with UAVs is often easier said than done. So consider the fact that the average farm in the United States is 445 acres, yet the average UAV battery life is 20 to 45 minutes. This means that each flight, you'll only be able to cover part of the farm, especially if you're hovering closer to the ground to explore things in more detail or get good data reads. So the question is, how can you maximize the information density obtained from your flight path? This work, which is a collaboration with my colleague, roboticist Steve McGuire, will be using a combination of simulation followed by real-world validation to design path planning algorithms that will make the most of limited UAV battery lifetimes. Building on groundworks like these, my dream is that we can transition from the traditional sensing paradigms to a more mobile and microbe-friendly future, making data-driven agriculture accessible for all. So with that, I'd like to take a moment to recap. Artificial intelligence has great promise at the intersection of sustainability, agriculture, and technology. But there's two sides to consider: sustainable AI and AI for sustainability. We first went over sustainable AI, which looks at how to train models using fewer resources and analyzing the costs of training versus anticipated model benefits. Next, we went over AI for sustainability, which uses AI to predict and reduce environmental impacts, and I went over some use cases from my own research in ag tech. In closing, I'll leave you with a call to action. As a research community, it's not sufficient to focus on one or the other. We must collectively pursue both sustainable AI and AI for sustainability to truly make progress. And furthermore, to address the institutional barriers related to lack of awareness, our research products should avoid rose-colored glasses, and we should encourage each other to frankly discuss the potential drawbacks of our work. For a great guide on how to do this, check out It's Time to Do Something by Hecht et al. We owe this to ourselves, our students, and society at large. So thank you all for giving me this time to speak today. Please feel free to reach out if you're interested in hosting a microbial fuel cell deployment or want to collaborate in other ways. And if you have any questions, I'm happy to take a few now.
No, that was great, Colleen. Really, really appreciate it. And I mean, to be delivering a presentation like that at 5 a.m. in the morning is amazing. So I can only imagine what you like by 12 noon. So well done. Fantastic. It's really, really good. And look, I love the way you brought it together. And look, anyone that knows me, I really like having a call to action at the end of any presentation. So I think there's a very clear call to action there around the AI for sustainability and sustainable AI. And I definitely learned something new about dirt batteries that I never knew about before. So well done on that. Open it up to the audience here or anyone online. If you've got a question or two, we can take one or two questions. If anybody has a question or anything you want to get more clarification on, just put your hand up or shout out. We've got ceiling mics, so everyone, Colleen will be able to hear us. Any questions, or is everybody just taking it all in? What's been shared? No question? No questions online?
I'm seeing a hand
Right.
raised.
Yeah, so hi.
Yeah, go ahead.
My name is Artyom, and I don't know, not just really question, but I was just wondering, what are low power wireless signals? And
Yes, it gets a little bit into the details of the work. So I have some extra slides. This one goes over it in some amount of detail. So kind of the idea behind the system that I was talking about previously is the key is that if you know the speed of RF, radio frequency waves traveling through soil, you can infer soil moisture. And the reason that you can do that is because the more wet the soil is, the slower RF travels. So the idea behind our work is if you put a reflector underground at a known depth and emit RF and measure the time that it takes to reach the reflector and travel back, you can do some pretty simple algebra, figure out how long it took that wave to propagate in the soil, and through a series of equations and leveraging the work of soil scientists decades ago, you can map that back to soil moisture. And this idea hinges on something called RF backscatter. And I don't think I have a slide in particular on that, but I think most of the audience has probably never heard of RF backscatter, but the idea behind that is that all matter reflects some portion of incident RF. And so think about something like radars or echolocation. You emit RF and it's going to bounce off an object and come back. And beyond simple echolocation, you can leverage this backscattering phenomenon to implement communication. And the reason that you can do this is that antennas are very effective at re-radiating this incident RF. So if you change the impedance of the antenna, you can change the nature of the reflection. So this is how you can do this communication for free, essentially free, that I was talking about earlier. The simplest way to do that is to have RF directed at the antenna and then toggle the antenna between a grounded and ungrounded state. This toggles it between maximal and minimal reflection, basically creating a reflected signal of zeros and ones. And that's backscatter in a nutshell. And the tag underground implements this kind of backscattering. And the paper goes into more details on why the backscattering is necessary versus, just putting a piece of metal underground. And, if you have any questions on that, happy to answer that, offline.
Sure. Thank you. Thanks a lot.
Okay. Any further questions? If there's no further questions, I think we'll move on. So look, again, Colleen, really appreciate your time and getting up so early in the morning to deliver this presentation. And if there's any further queries, we'll come back to you. And you're more than welcome to stay online if you want to hear some of the other talks that'll be happening throughout the day. The whole focus is around AI for sustainable agriculture. So there should be some very interesting talks over the next couple of hours. But thanks again, Colleen. Okay.
Likewise. Thank you.
I guess one of the changes we've made this year is if anyone's at the AI Summer School over the last couple of years, we generally kind of had the academic presentations on day one and they were followed by the industry presentations on day two. And I suppose we listened to the feedback that came back from the customer surveys last year, and it was very clear people wanted to kind of have both the academic and the industry presentations happening at the same time. So following that, the next presentation is actually going to be from industry. So I'm delighted to welcome Gavin Shorten. Gavin is the innovation leader for the IBM Open Exchange, and Gavin's going to talk about sustainability in action, an enterprise point of view on the industry, state of the art and the opportunity. During this session, he's going to take a whistle-stop tour, this is his words, not mine, through the dangers of greenwashing, exploring the data, governance and AI applications of technology to sustainability, examples of the current market offering, the state of the art and the opportunity for high potential startups and scale-ups will also be discussed. And I know, IBM and Gavin have been doing a lot of work with Jason and Zavatar and supporting what we're doing here within the RDI Hub. So I also want to just call out the support we get from IBM and the support that Jason has got from Zavatar as well. So over to you now, Gavin, for 20 minutes.
Okay, thanks, Mel, for the introduction. As Liam said, my name is Gavin. I work in a team called the Open Exchange. So we drive partnerships for IBM in Ireland, and we've actually been piloting a program across Europe for the last 12 months. I'm not going to get too much into the blur, but basically we're really focused on what we call a co-create model, which is that we really go hands-on with organizations. And the idea is that we accelerate their go-to-market and internationalization with our technology. And we're really focused. From an Irish perspective, for example, we serve almost the entire market through our partners, so we don't even sell directly. So we're really laser focused on that. In terms of sustainability, I wanted to make this point because I think it's really important. AI in itself, we've seen a huge buzz around it, which has been fantastic. But we've also seen a lot of ethical concerns being raised about the use of AI. They've been raised over the last number of decades, but particularly over the last 12 months. We built a machine 30 years ago, I think it was, that beat the world chess master, and everybody freaked out and said, oh my God, no one's going to play chess anymore, and humans are not going to play chess. And now, of course, that's not what happened. But there are really legitimate concerns about how you apply AI technology. And then you have sustainability, and there's legitimate concerns about greenwashing, which is where people think challenging climate change or talking about sustainability is actually just a great way to market your organization. And when you talk about putting the two together, you can see how we have to tread carefully. And Colleen touched on some of this earlier on. And I think it's really important that if we're going to adopt AI technologies and sustainability, that we're quite serious about how we do it. Okay. As an organization, we have our own objectives that we're trying to achieve around our own sustainability portfolio, but we're also very interested in investing in that space. So we have a ventures arm, and obviously we do a lot of acquisitions. So we've been spending quite aggressively in terms of building out our own sustainability portfolio. Why are we doing that? Well, one of the reasons we're doing it is, and you guys, there's a lot of people in this room who've probably forgotten more about sustainability than I'll ever know. But one thing I do know is it's really complex, and it's really complex based on the types of considerations and the questions and the problems that are presented when you try to bring a sustainability solution to the market. So you have your environmental concerns. So you're trying to drive down emissions. You're trying to do all the great stuff that we just heard about. You're trying to improve the social impact that that's going to have. And increasingly, if you don't, it's really going to cost you because you're going to get fined or you're going to be found to be non-compliant. And that can have huge impact on your brand as well. So it's a very complex space. This is before we even start to go down the rabbit hole around generative AI and how complex that becomes. Sustainability is tough. Okay, but one thing that we can do, and I'm very much coming at this from a commercial perspective or from a business perspective, is if we try to not oversimplify it, but boil it down really into what kind of AI solutions in sustainability are going to work. All organizations want to optimize their costs and their operations because there's really only two ways to compete commercially. You do it on cost or you differentiate. When it comes to sustainability, you can kind of differentiate actually through your sustainability agenda, and you can reduce costs. So when it comes to reducing waste and emissions, there's actually a huge opportunity. There's a huge commercial opportunity. And if you're building solutions or you're creating a startup organization, you can tap into this. So there's a very real, even beyond the social and humanist considerations and aspects of sustainability, there's a real genuine business opportunity here as well. Couldn't go past today without talking about generative AI. Liam got there before me talking about ChatGPT. But is the market really ready for it? So we have this saying, which kind of started out as a joke, and my colleague Noel is over here from IBM as well. At IBM, we don't think AI is about writing poems about cats and dogs, right? Which is some of the things we've seen on the radio or the news over the last while. For starters, some of the models that are out there cost $150 million to make. And again, we've just seen the amount of carbon that produces. So if you're going to build a generative AI model, it should probably do a bit more than writing poems about dogs, okay? And then if you're going to bring it into a business, what organizational leader is going to trust generative AI with their client information, with their employees, with their profit margin, okay? And what we've actually seen is, sustainability aside, there are a lot of concerns out there around the use of AI technology in these spaces, and a lot of them are ethical. So can you explain to me where that result came from? We talked about ChatGPT. For the most part, we can't explain where the answers came from. What was it ethical? What information did you put in there? Where did you source it from? Who owned the copyright on that? Loads of questions around this too. Bias, we've intentionally as an organization taken our facial recognition technology off the market because there's a huge opportunity to introduce bias and trust. Can you actually trust what's been generated? The good thing is there is an ethical way or a core way. And again, I remember I do work for a multinational organization. I am commercially focused, but to do this for real in an ethical way, which is the only way to be successful, we believe it's based around 4 principles, which is that you have to be open. And I'm going to talk about contributions to open source and building on open source tech a little bit later on. It needs to be targeted. So again, no poems about cats and dogs. So we're actually building models that make sense and unlock value for people. It needs to be trusted, which is secure, and then it needs to be empowering. So it should really run anywhere. It shouldn't just run on your large scale data centers that are based around the world. Okay. So AI in general, again, you're going to hear from a lot of experts about AI over the next 2 days. Where we see our point of view is AI is now moving from where we started, which was we had solutions where we decided we would put AI into. So really simple example. You run a retail website and you put a bot inside it, and the bot can answer questions and kind of understand what people are asking them, and it can respond. So that's plus AI. We're adding AI. What we're increasingly seeing is, and again, because I work with so many startups, I get to see what's coming out way before even we get there, is that actually the AI is now the solution. So there's an artificially intelligent piece of capability that actually is the offering, and they're going to build out all the rest of their organization around that, or at least the rest of their solution around that. So there is a significant shift in terms of where AI is at on the ladder, as we call it. So we've spent a really long time working to build technologies to collect and organize data. We're still not finished there either. And really, it's to do that. We've already talked about the mass quantities of information that's needed to build AI that you can actually trust and use to consume to actually do work. Okay. And then probably for the rest of my lifetime anyway, AI will be replacing automated tasks, redundant tasks. And what it'll actually be doing is taking away the opportunity cost that we have by applying human expertise and skills to do jobs that we could teach something else, a piece of technology to do. So we're looking to replace the workflows and free up that capital, that human intelligence and capital to go do more meaningful things. So coming back then to sustainability. So before we talk about AI, which is right down here, when we talk about the data challenge for sustainability, look at the number of different volumes of data that we can talk about. Now, as a company, for us, that's great because we're big. We have loads of solutions across all these different paradigms. But when we talk to startup organizations, we ask them, which ones of these silos are you going to be using and collecting data from? Who's going to provide you access to the data? Do you have consent to collect that data? What are you going to use it for? Is there any bias in that data? Then we talk about all the systems that are already in place. So all of this data, for the most part, tends to live somewhere already. It might be on the edge, like we said, and you have devices that you want to collect it. But it could be inside a building management system. It could be inside a compliance framework that people use to be certified. It could be inside an asset management system. So if I was building a solution from scratch, I'd be asking myself, what slice through this stack is it that I'm addressing? What data flows or what pieces of data am I going to need? Who's already built stuff? We're really great at thinking we're going to reinvent the wheel. I'm going to create this thing that does this thing that 50 other people have already done. And what, like, how are we going to connect in with what's already there? And then on top of that, we have so many different computing paradigms now. We talked about the cost of running them, but we've also got some really efficient ways of doing things now. A Raspberry Pi is very powerful. The phone is very powerful. We talked about this earlier on today. So how are we going to store and collect the data? And then we can start to talk about artificial intelligence, okay? Or more importantly, we can talk about analytics. As I always say, we used to call it analytics when I was in college. So we can then talk about building out solutions. So in terms of like when we look at sustainability as an opportunity as a business, We see an opportunity to apply technology across this whole paradigm. And we have a view of what that looks like for us. And even a company like IBM, we still just pick pieces of that pie that we think we can compete in. So we have our sustainability strategy and roadmap. I touched on that at the start. Then we have ESG data reporting and risk management. We acquired a company called Invisi. There's a startup that's going to talk as well about how you can read out on carbon footprints that's on the agenda. This is really just about reporting and providing out risk scores. This is huge because back to the governance piece I talked about before, remember, environmental, social, and governance. You have to be able to report out on your social and environmental impact. So there's a huge opportunity to build technologies to help you do that. When you think about the types of data and the breadth of data that's there, think about how tough that is. Then you do environmental intelligence suites. That's more about Earth observations. And then we have asset management and responsible and green computing. I don't need to talk about this because Colleen already did a much better job of it than I can. Okay, so the state of the art. Where are we actually at with this? What are IBM using AI for? So again, generative AI, really it's about using mass quantities of data to build a model. And although that model might be really expensive to produce, if you pick the right one, you can take that one model and make it really easy for hundreds of other organizations, hundreds of other companies to then build their solutions around it. So we've been working with NASA. We've just open sourced the model that we built, where we took 1 year of Earth observation data. We labeled it, and we labeled it to detect floods and scorch marks on the Earth, so forest fires. And the idea was that then now you have a model that you can feed in imagery data, and it will automatically come back and tell you what the chances are or risk is of a flood or a fire in a particular area. And we improved the accuracy by 15% using generative AI tech. Now, where the generative piece comes in is you can take that model, and by using tuning and prompting, which I'm not going to get into too much of the details on, but you don't have to reinvent the model. You can tweak it basically. You can apply that same model to look for crop yields. You can detect and monitor greenhouse gas emissions, and you can look at deforestation across the globe. So, no singing dogs and cats. We're building a model that's actually we built one model which was designed to detect forest fires, and now it can be used to look for crop yields, to measure crop yield, like how are crops performing, look for detect greenhouse gas issues, and where there might be deforestation. Because obviously that happens in parts of the world that we don't necessarily have a lot of observability over. This is a much more local one. And as I said, I work a lot with startups and universities as well. We do a lot of R&D projects. This is a European project which has been funded by the European Union. In this case, we're working with 3 really, really big shipping fleets that operate mostly around the Med. And what we're doing is we're digitizing the operations on the ship. And the idea is that by capturing the data they have, we can build a digital representation of the ship and its operations. And then we can do all sorts of cool things with artificial intelligence and analytics. But instead of actually trying to trial it on 100 different ships, we basically build like an emulated environment where we can test things out. And then only when we're really confident do we go down and invest the money that it's going to take to actually deploy it into the fleet. So the idea is we build a digital twin, and then we build off our analytics and AI technologies over the back. And again, I know there are a lot of academics online and in the room who are probably very familiar with these funding frameworks, but for startup companies or even high potential startups, this is a really good way of not just getting funding, but of tapping into the European network. And I know RDI Hub are experts on this as well, so good place to reach out to. So where to go next? I just wanted to leave this message because it's one that's close to my heart. So over the last year, it's become more difficult to raise funds for startup organizations. There's a realization across the whole thing, Silicon Valley Bank and lots of other examples we've heard about where there was a big focus on storytelling, great ideas, not necessarily on the basics around organizations. Profitability, are you building something real? Okay. The great news is when it comes to climate tech, people are waking up. As Liam said, it's 27 degrees today in Kerry, and then last month it was cold and it rained for the whole month of August. So there's something weird going on. None of us can deny that. There's a huge amount of investment going into this space. So for startup companies that are looking for AI and sustainability use cases, or looking to go to market, again, it's a really tough. Trust me, the rest of the graph for other industries doesn't look like this. Last year, they were up. The amount of funding raised for sustainability startups was 90% higher than it was before. So this is a really good place to focus your efforts. Again, it provides social, environmental, and governance advantages. But of course, commercial organizations like to make money as well. So it's a really cool place to start. So that's really a really kind of rushed presentation a little bit about what we're doing in the sustainability space. If anybody wants to check out some more locations for information about what we do, or if you want, you can reach out to me directly, or if you want to catch up with us later on, as they said, Noel is here from IBM, and he owns the cloud business for IBM in Ireland. We'll be really happy to chat with you. Okay.
Thanks, William, Gavin. Anybody, just wait a second. Anybody, any questions for Gavin here in the room or online?
Sure.
Yeah.
On that model, this is here quite a few metrics. On that model you built in NASA, right? Have you talked to financial service companies? I mean, you had as well this kind of an opportunity to insurance companies that like on how to, actually explore that in a sandbox environment.
Yeah. What's the question?
To explore partnerships around that model is just
Around risk management?
risk management and your open source model.
Yeah, we have. So we're going to.
You might just call out the question again, just so people online can hear.
Sure. So have we,
Yeah.
if I understand the question correctly, have we explored commercial opportunity for risk management using that model? Yeah, absolutely. We're two things. One, we're actually putting that model, we are commercializing the model. So it's open source now, it's in Hugging Face, people can access it, okay? But we're also commercializing it inside our own environmental intelligence suite, which we sell to insurance providers and governments, specifically to look at flood risk management and all that kind of thing. And Noel actually does a lot of work with financial services consultancy agencies around flood risk management and data warehousing and stuff like that as well. And this model very much feeds into that. So you're bang on. Any other questions?
See, a change in the last year or so, driven by the EU corporate sustainability reporting directive.
Yeah.
Like, is that driving a lot of demand for the reporting type, particularly that you noticed?
Massively, yeah. We're embargoed on what we can say, but we're in talks with a number of different organizations locally and globally around building predictive capabilities. First of all, collecting all the data to report out to governments is nearly, it's a challenge in itself. But then building an ecosystem of solutions providers to the financial services that have to do that reporting is a huge opportunity. What's interesting is, I think the financial services industry is moving a little bit slower to build those solutions than we thought. Is it next year, I think, or is it the year after? Next year, I think, is it not?
April next year.
The penalties could start in April next year for not being able to report out that European directive information. So I have a feeling people are going to take it a lot more seriously next April. Yeah. Anybody else? No? Great. Thanks a million, folks.
Okay, so we're just transitioning online now just to see if Caroline is with us. So I'm not sure, Guru, can you check to see if Caroline Lair has joined us? Oh, there she is. Good afternoon, Caroline. I won't introduce you in my Irish French because it'll sound really, really bad. So, but listen, you're more than welcome. I'm delighted to have you here. So Caroline, as you can see on screen, is the founder of the Good AI, Tech for Sustainability. The Good AI is empowering companies, startups, and talent using AI to address sustainable challenges in various industries. She's also co-founder and board member of Women in AI. And what I also found really interesting, I was looking at your LinkedIn profile this morning, was the company you have, Instellar Lab, develops modules for sustainable living on Earth and in space. So I'm really interested to get to understand the whole Earth and space element as well. So look, delighted to have you here. I know you're under a lot of time pressure to make it today. So look, I'll hand over to you to present for the next 20 minutes, and then we'll get some questions at the end. So thanks again, Caroline, and the stage is yours.
Thanks so much. So actually, I didn't plan on talking about Interstellar Lab, but I can tell a few words, and thanks also for your understanding, because we actually right now signing the very first contract for Interstellar Lab. So it's a lot of big time and a lot of pressure. But I'm really happy to be here. I'm going to share my screen now. So I have a few slides I want to share with you. Okay. So let me put that full screen. Okay, can you see full screen? Is that all right?
Yeah, no, it's all good, yeah.
Great. So a bit, maybe a bit, I want to start with a bit of my journey in the field of AI. So I have actually a business and political science background. I'm not an engineer myself, and I hope it can give a hope to many of you if you're not technical. You can still work in that field. And I've always been working in tech, but to be honest, like a few years ago, I was really about to leave the industry because I was really missing purpose. And I was not feeling I had like a real impact. And this was until I started to work in AI back in 2018, when I joined a startup who was doing private by design voice assistant. So for tech people, we called it embedded voice recognition. So basically the concept was to recognize language without sending your voice to the cloud. So the voice was processed locally on a device, and it was enabling privacy. And the company, so this company was named Snips, was a French startup, was acquired by Sonos end of 2019. And so when I started working in this company as biz dev, basically I was the first to join the business team. I was really amazed by the power of AI and how it was shaping society. In fact, algorithm, as you know, they're really used everywhere, and they guide us like in every decision making when it comes to health, justice, work, education, learning about our conscious and unconscious patterns when we train algorithm on data. So it really acts as a mirror of our society. And this is also why back in 2018, I also co-founded a nonprofit called Women in AI, who is today gathering more than 13K women in 100 plus countries. We created this organization because my co-founders and I, we really strongly believe that we can actively shape a society in a fairer and more inclusive way thanks to AI. And this is possible only if we are aware of how AI works, and especially when it comes to the risk of discrimination towards women and minorities. And to get there, we need way more women in the field because they also act as the first safeguard to identify reproduction of discriminative gender bias in algorithm and correct them. And as you know, today we have still too few women in the field of AI. Like I think it's around 20% of AI teams. AI teams who are mostly male and white most of the time. So this is what we're doing with Women in AI. And so Snips, the company was working in, was acquired by Sonos end of 2019. And then I was wondering what I will do. And I really wanted to keep supporting entrepreneurs that were willing to leverage AI for good. So I started The Good AI, who is a community of 140 plus startups and around 200 individual experts, all in the field of AI for sustainability. So what we do is that we select all those experts, we give them visibility through events, peer-to-peer learning, and we connect them with corporates, big corporates, big companies that want to use AI for good, and also to achieve their ESG goals. So today, I want to challenge you all a bit. So I understand that you're all very interested, passionate, maybe experts in the field of AI. And so for sure, you are change makers. And with AI, you really have, I think you really have gold in your hand, because you have the power to improve and shape the world. So I really want to challenge all of you, and that's too quick, to use it for good, because I really believe we don't need another AI-based solution to maximize clicks on ad. We don't need another solution to generate multiple avatars in the metaverse.
Caroline, I think you're just gonna on mute. You just got on mute there on your screen. I think you've put yourself on mute. Yeah.
Okay, that's weird. Okay, so let me go back. So I don't know when you stop. I'm not sure. I was saying that basically we don't need AI to maximize clicks on ad or to generate some new avatars, in the metaverse, but we need to really look at the challenges we're facing as a species, as a planet today, and take a step back, as business leaders, as industries, but also as human beings, as AI practitioners, and basically understand what is our purpose and how we can contribute to create more social and
You just muted again.
okay. So I don't understand why it's okay. You can hear me now?
Yeah, we can hear you now. Yeah.
Okay. So yeah, I don't know where it stopped. But I was mentioning as well that, as you may know, AI also, when you use AI, I talk about it with the bias, but you also have AI has also an environmental impact. So we also need to be very cautious when we use AI. And yes, right now, I mean, we all know that this is when we are facing challenges that we can be very creative and ingenious. And what is great when it comes to AI today is that we have a very interesting ecosystem. Like the AI for good revolution is really happening. And we have a lot of initiatives all around the globe, whether is it private companies, startups, citizens supported by organizations and communities such as the Good AI, Data for Good, Omdena. So you have a few examples here. So there are a lot of resources out there to really leverage AI for good. And why AI is really interesting when it comes to doing good is because it's a very powerful technology, as you know, and it's a tool that can help us, measure current trends, identify patterns, optimize and predict how we can handle a transition to a more sustainable world. And it also helps us to think out of the box and create new models. So I'm going to share a few examples with you today of concretely how AI can help us create a more sustainable production of goods and services. And so here we have 4 images. They represent 4 industries: electric system, buildings, transportation, and industry manufacturing. And those 4 industries, what they have in common, so they are among the most polluting industries in the world, together with agriculture. And they also are using AI technologies for performance, but also to drive a more sustainable revolution in each of these industries. So for instance, when it comes to AI to decrease carbon emission, there are a lot of great opportunities. That according to BCG's, AI could help reduce 5 to 10% of GHG emissions before 2030. So some of the key application AI can address are here. So for instance, in the electric sector, you have the possibility to better forecast supply and demand of electricity in order to help transition into low carbon electricity. In the field of transportation, you can optimize freight routing. And in the industry, you can use predictive maintenance, work on reduction of food waste. And finally, of course, when it comes to carbon accounting, there is a lot of initiative using AI to collect data all along complex supply chain and measures emissions. So these are only a few examples, basically, of how AI can help decrease carbon emission. But you can find way more example in a very interesting paper. So I think there is the reference here on the bottom of the slide. The papers is called Tackling Climate Change with Machine Learning, and it's from Climate Change AI community. And there are hundreds of applications to use AI and work on climate. So I mentioned also that AI was really interesting to think out of the box, to enlarge our thinking scope at the very beginning of the production process, basically at the design stage, because we need to learn how to build products that survive the long term. And this is really true for fashion, for packaging, for architecture, for examples. Basically, what we need to do today is to look at the entire life cycle of producing something and ask ourselves, how can I produce this by using the least amount of energy, protect the environment, conserve water, think about multiple usage and ways to recycle it. And so this is what we call generative design. And AI can be a tremendous help here, because it can help us basically to merge sustainability and design and provide a different scenario that we may have never thought about. So transitioning to a more sustainable world is not only about mitigating and adapting to climate change. It's also about creating human-friendly working conditions and respecting human rights all along the supply chain. And I really like the three examples using leveraging natural language processing. So we are supporting three examples of projects and application of AI, the Good AI, that corresponds to this application. So the first one, basically, when it comes to modern slavery, you can use NLP to read, and benchmark modern slavery statements of companies. Another interesting application is to monitor mental health of employees, predicting burnout, identifying cases of sexual harassment through anonymous analysis of communication, and this is GDPR compliant. And the last one, of course, is to encourage diversity and inclusion with bias-free recruitment algorithm. So do three examples again. There are three startups that we are supporting at the Good AI. So as mentioned earlier, AI for good is not only about application for good, it's also about using AI responsibly with regards to people and the planet. And here you can see 7 principles from the Berkman-Klein Center of Harvard University. And I want to stop on 2 of them, especially because those 2 were among the top priorities of a big company in tire manufacturing that we've been working for at the Good AI. And so among all those principles, the 2 most important for them were fairness and equity and green AI. Interesting for tire manufacturing. So when it comes to fairness and equity, as I was saying earlier, with AI, you really have gold in your hands, but it's raw gold. It's raw gold. So it does require work to be sure to get the best out of it. So as the business leaders, industry leaders, AI practitioners, you all have this responsibility to make sure when you use AI that you don't participate in reproducing and amplifying discriminative bias based on gender, age, handicap, or ethnicity, etc. So it's hard to do. It's not easy, but today there are more and more tools to help you. So I'm thinking, for instance, about Azure, that is providing some tools to detect possible bias. You also have library like Fairness to correct data before treatment. We had a learning session at the Good AI with CTOs exactly on this topic a few weeks ago. And of course, what is key is to make sure that you have diversity in your team. I will never claim it enough. And you know, we all remember this story about Apple, who forgot to include the periods in a health app for women because it was designed by men. So it's really key to make sure you have enough women and diversity in your team. The second topic, green AI. So we talk a bit less about it, but it's also really it's some topic that is really important to have in mind. It's preoccupied. I mean, it's a topic that is we don't have that much solution so far, and it's a real issue today. When you look at the projected growth of global energy consumption of the ICT sector, so ICT is information and communication, the most optimistic scenario accounts for 7%, and the most negative one accounts for more than 20% of global demand by 2040. And most likely because of the extensive use of deep learning. And deep learning is especially really carbon intensive and in an exponential manner. As you can see, the computing resources required to create best-in-class AI model doubles every 3 to 4 months. So it's really a problem that we need to solve. And there are good practices to adopt, actually a lot of them, when it comes, for instance, to the choice of hardware and infrastructure. When you're gonna choose, for instance, where you want to locate your cloud server, you should, for instance, check the energy mix of the country where your cloud provider is based. It's very different, for instance, to have your server in US and Germany versus Brazil and France. When you choose as well some training methods, when it comes to deep learning, for instance, the use of transfer learning and pre-trained model can reduce training time and data requirements. And of course, we also all need to be super transparent and communicate about the carbon footprint of our AI solutions. Yeah, so these are topics as well we've been working on with the startups and the experts from the Good AI community, trying to come with some principles and apply them. So this is, yeah, really briefly also to finish with this. So as I was saying at the very beginning, so at the Good AI, we trying to build this community of entrepreneurs, thinkers, and resources of AI-based solution to really help big companies to be more sustainable. We've been working with Michelin, Nestlé, Pernod Ricard, helping them on different topics, from designing some ethical principle, or to show them how they can reach their ESG purpose thanks to AI and different solutions provided by startups of the Good AI community. We also organizing the first Good AI Awards next year. So if any of you are interested to join a partner, feel free to reach out to me. And finally, I want to finish with this thought from Steve Jobs, and I hope it will resonate with all of you. So we often think that technology is the solution to everything in our industry, but it's actually not true. It's just a tool, and it's not going to replace policies, for instance. And in fact, many technological tools have been available for many years now, but they haven't been adopted at scale by society yet. So it's really up to us, to you guys, to take the decision to act upon it and to really use AI for good. Thank you. If you have any question, I'm happy to answer.
No, that was really good, Caroline. So really liked some of the examples you used as you were going through. So as Caroline said, we open it up to any questions online or any questions from the audience. I suppose one of the questions I would have, Caroline, is I'd love to get your thoughts. You mentioned about for AI to be successful, we need to get the gender bias sorted. We need to get more women into AI and working AI. What are your thoughts about doing that? I mean, how do you feel we should be going about doing that? Is it something we should be doing within our education systems, or how do we get more females involved in artificial intelligence?
Yeah, it's a good question. So actually, and with Women in AI, we've been organizing a lot of workshops with teenagers. And what we're seeing is that until the age of 12, 13, 14, they're really interested in AI, in robotics. They're passionate about it. But then after, we're losing them. So when they turn 16, 17, they're losing interest in AI also because I think at school, they're not, teachers are not really pushing them toward engineering studies. Parents, it's the same for parents, by the way. So yeah, there is a lot of work to do between age 15 and 18, not to lose, for them not to lose interest and still think that they can also be part of this world. And that's why we trying as much as we can at the Good AI to promote role models, to show them that there are actually a lot of badass women in this field doing a lot of great stuff. And even that the inventor of a lot of AI techniques are women, actually. So it's a lot about storytelling, role models, visibility of women in the field to encourage younger girls to join. Another very, very interesting point, actually my co-founders, Women in AI, they are Iranian and Lebanese. And we just find out that, as you may know, in Iran, a lot of women are engineers, a lot. And because they haven't been to school with boys, so they don't compare to them. And for them, being engineers mean they're also going to get, sustainable revenues and be financially independent. So they don't hesitate to go and learn. And that's why you actually absolutely don't have any lack of women in tech industries in Iran, same in India. It's really a Western issue. It's counterintuitive, but it's actually we're missing a lot of women in the Western world in the tech industry. So it's even more our problem.
No, that's good. I'm going to go to Jennifer with a question. But just before that, I mean, just one initiative we've been kind of driving here in Ireland, and two of the partners involved in the initiative are here in the room, is we run a STEM Passport for Inclusion program where we bring in girls from disadvantaged schools in here to the RDI Hub. It's done in collaboration with the Microsoft Dreamspace program and also Munster Technological University. And we bring the girls through 3 lab days, and as a result of it, they get a level 6 certification in STEM Passport. And then they get 50 points towards their CEO course at Munster Technological University. And we've seen that as a game changer. I mean, some of them, the women that come on as mentors, from Microsoft, VMware, and the other companies, really inspire the girls. And like we've had girls in that program that, just wanted to take over the local bakery or the local farm, and now are actually doing engineering in Munster Technological University or UCD. So I think it is about getting it, and that program has been driven by an amazing woman, Katrina O'Sullivan. Jennifer, who's been on our NDRC startup programs, do you want to come on there with your question? Great to see you again.
Yeah, thanks, Liam. Hi, Caroline, it's brilliant talk. I've really enjoyed it. My question is, I'm helping Tech Founder Ireland. It's a group of founders, but it's very inclusive to women founders, and you don't have to have a tech background to start a tech company. But we've recently launched a book club. So I'm taking this opportunity to ask you, is there any books that you would recommend that would, be around AI and sustainability, or any just books that you have that you recommend?
Oh, let me check my Kindle. Because I actually don't have the title in my head right now. Blah 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 blah. There is one called Super Intelligent from Nick Bostrom.
Super Intelligent.
Super Intelligent from Nick Bostrom.
Okay.
There's also one called AI Superpower, China, Silicon Valley, New World Order. This is more about geopolitics of AI. And I think I have others, but they're not here. So I'm definitely happy to send you a list.
Perfect. Thank
Just like my
be
email, don't
Thanks, Emil, for that.
The Atlas of AI, by the way. Yeah, the Atlas of AI by Kate Crawford.
Okay,
This one is good as well. Really cool.
great. Thank you.
You're welcome.
Thanks, Jennifer. Any further questions? Oh, there's another question in chat window. So I don't know, Caroline, can you see the chat window there? But Lynn has put in a question saying, I've pivoted into digital transformation AI in the past 3 years to add to my existing skills. Are there any core skills, courses that you would recommend for somebody transitioning into AI from a non-tech background? So what are the kind of key skills that you feel are needed for a non-technical person to transition into AI? And any of the other professors that are in the room jump in as well, Joseph Walsh, Vinnie Lynch, Brendan, if there's particular skills you feel are needed.
So on the Good AI website, the Good AI website, we had some kind of resources chapter, and we had listed all the courses, the MOOC courses available on website like Coursera. We did that 2 years ago. I'm not sure it is that updated. The website has evolved right now, so it's not visible anymore. But like, just email me. I'm just putting my email again. I can try to send you a list. But what I will say, definitely, it's good to have a mix of technical but also ethical. Yeah, to be aware again of the impact of what we do with AI. So always mixing technical and ethics of AI. Also, how we can use AI in a green way. This is really, really important. It goes all together.
Okay, great, Caroline. Yeah, I know Claire has put a question. Is that Claire from Edgewoodstown up in about Microsoft Dreamspace? No, different Claire? Okay, I'll follow up with you on the STEM Passport program separately anyway, Claire. I'll get some information to you, okay? Anybody any further questions before we let Caroline go?
If anyone, by the way, we have a chapter in Ireland, a very active one. If you want, Women in AI, if you're interested, I can also put you in touch.
Okay, cool. So look, Caroline, really appreciate your time. I know you're really busy. I know you've a lot going on between the Women in AI and your own business and your own startups and stuff. But that was really inspirational what you shared with us around the Good AI. So thank you for your time today. We really appreciate it.
Thanks so much for having me.
Okay, I think we might just go with a little bit of a change on the agenda, because I think we were planning on going for a break, but I think we've good momentum going. So we might just go over to Joseph Walsh for the next 30 minutes to go through Joe's presentation. Then we'll break for tea and coffee, if that's okay, if everyone's okay with that. Yeah, and you have a clicker here as well, Joe. So let me just, while Joe's getting that, I'll just do the official introduction. So Joseph Walsh is on our is from Ulster Technological University. Joe is a fantastic sport with the RDI Hub. He's been on our advisory board for the last 4 years. And Joe's going to talk about how the utilisation of AI in sustainable agriculture will be a driving force behind the fourth agricultural revolution. As I said, Joe spoke at the AI Summer School 3 years ago when we did around AI for sustainable societies, and he gave some fantastic examples that day. So I'm really interested to see how his research has moved on over the last 3 years and get Joe's insights into the whole sustainable agricultural space. So I'm going to hand over to Joe now, and Joe's going to talk to us instead about how the utilisation of AI in sustainable agriculture will be a driving force behind the fourth agricultural revolution. Thank you, Joe.
Thanks very much, Liam, and absolutely delighted to be here to give my thoughts on this particular topic area. As Liam said, I think I spoke at the very first one, which was right in the middle of COVID time, so it was a virtual event, so it's great to get back to some face-to-face interaction, certainly after that time period. So, I think it'll work. I suppose I'm from the Kerry campus of the Munster Technological University, and we would have a very proud tradition of agriculture and engineering and agricultural mechanics and agricultural science. So particularly that's why I think I've fallen into this particular area, an interest in agriculture. And as a result of having, I suppose, programs and students that have gone through the university for a long time, probably over 40 years now, we have great connections in all of the Irish agri-tech companies and ag science companies. And I think that is a great testament to the staff that have been involved over the years. So what I'm going to do is maybe just set the scene a little bit first, give some, I suppose, my thoughts on technological advancements, trends in AI and agri-tech, current projects, and maybe then I'll talk about our own Agri-Tech Centre of Excellence, which is based in the Kerry campus of the Munster Technological University, and what we're doing around immersive technologies. I think when you mention agriculture, you have to think about sustainability at the same time, because obviously those two words should be intertwined when you're discussing anything going forward. And obviously, how can AI fuel what we actually need to do in those two areas? So we need to certainly produce more food, and we need to do it sustainably. So we have 11 billion, heading for 11 billion people on the planet by 2050. Obviously, that is of massive concern when you think about each year the world's farms must produce or feed 80 million more additional people. The world's population has nearly doubled since 1970 and is heading towards, as we said, 11 billion by 2050. Obviously, this puts a massive amount of pressure on what we need to produce and farms and agriculture and how we need to do it sustainably. Another graph that I always like to show is that the United Nations came out with a prediction in 2015 where by, I suppose, 2100, we could have a situation where there's almost 15 billion people on the planet. 3 out of 5 will be from the continent of Africa. Hopefully all of that, all of those individuals will be brought out of the poverty line. They will require more food. And when they become more affluent, that is going to create another massive problem for agriculture, production, and obviously our sustainability. So farms in the world, there is about an estimate of 270 million farms globally. The size and productivity of these farms really vary from country to country. And that's something that is really important when we look at economic development, poverty, and obviously global food production and environmental concerns and issues. So if you take an example in the US and show how this, I suppose, disparity happens in production of food and agriculture. In the US, the average cow would produce about 10,300 litres of milk per year. But then if you go to India, you're looking at a cow would produce maybe 1,600 litres of milk. If you look at globally, there's about 270 million cows producing milk around the world. Obviously, that would share between the Western world. But milk production in Asia, which wasn't traditionally something that was extremely popular or common, has risen extensively over the last number of years. And I think there's about 20 million cows currently in China. And obviously, they're very interested in milk, I suppose, the baby milk powder and that type of formula, which is very important. So as countries become more affluent, right, there is a natural progression where they consume more meat. So as Asia has become more affluent, as Africa will become more affluent, more meat production will be required. And that is something, as a trend, you will see, and we have seen since the 80s. So that means that we have a growing global population. We have a population that will be becoming more affluent, and they will require more production of meat and food and agriculture, which is obviously going to put a massive strain on the whole system in the next 20 to 30 years. So if you take it as a whole, we haven't produced enough food around for the last 5 years. Obviously, we can make an argument about issues that we have in the Ukraine, COVID, but it's there as a fact. If you take it, we need to produce about 70% more food, and that would be proteins and milk. By 2050, since we'd say the 1990s, there has been minimal increases in the likes of maize, wheat, rice, and wheat. And I suppose another thing that we're mentioning, you know, there's a question mark here. We are facing a world food crisis, but if you look at 1/3 of the food that we would take home in the Western world would go straight into a landfill. So 1/3 of our food that we produce and buy is going straight into landfill. And if you go to the States, and I was actually there myself during the summer, the amount of waste that you see in restaurants, it is absolutely incredible. And we're now facing a world food crisis, but up to 30 to 40% in the Western world of the food that we're producing is going straight into landfill. Like, obviously, that is something that we need to look at. Can we produce more? I suppose by just increasing nearly 2% per annum, it will be enough, but obviously there's massive challenges associated with that. So this is where I suppose our technological advances come in. So if you go back 5,000-10,000 years, you know, there has been a massive amount of innovation, and innovation has been accelerating exponentially. But you must remember that, and this is a slide that actually just came across recently, if you go back 10,000 years after the last ice age, if it wasn't for agriculture and the ability to store food, none of this would have happened. Because when we were hunter-gatherers, if you have to worry about feeding yourself or your family the next day, you're not going to be creative, you're not going to be innovative. So it's as a result of agriculture that we have been able to go on this particular trend around innovation. So we can innovate, but it is going to be a challenge. So if you look at farming or agriculture as a whole, McKinsey did a report around what sectors had adopted digitization the most. And agriculture and hunting were actually the last on the list. So they haven't adopted digitization. If you look at a lot of farmers, they'd still use just notes like this. And why do they do it? It's because, you know, their parents did it. That's the way they've always done it. But obviously moving forward, like a simple example, if you have to go out and go use a plate reader to read the grass height in your fields or pastures, you know, that is you using a lot of time where you could have a simple system that is remotely doing that, monitoring that for you. And that saves time for you to do other tasks, which can improve your food and your agricultural production. So if you look at the cycles, and I like to kind of give this slide around crop product flow. So from sowing the seed to monitoring, harvesting, you would have crop maintenance, farm gate stuff, and then your processing side, transportation, logistics, supermarket, consumer, and right back. So that type of circle. And these are the Irish companies that are involved. Sustainability has to be interwoven as a result of population, climate change, everything that we're talking about. But there is a lot of innovation that we could go in each of these areas. And even with, I suppose, even with the crop cycle that we have outlined here, I would see that in time there could be a lot more joinings between this particular cycle. You could have farmers markets, you can have different types of production that you could incorporate across this type. History, instantly on your mobile and on the farm, and being able to interconnect all of that activity, store it in the cloud, and to be able to interrogate it and be able to provide people with information regarding the food security, etc. From an off-farm perspective, I think there's a lot of opportunities there. From an on-farm perspective, I don't know, lads, my clicker isn't working here. Will I go this side? Okay. So from an on-farm perspective, certainly I think there's, and this is cloud-based monitoring, we can have automated techniques to configure sensors to avoid, I suppose, you know, data that may not be accurate. We can have adaptive techniques to ensure data confidentiality, blockchain, which is very important because we need to have a ledger of everything that's happened. And basically this then can provide meaningful feedback to consumers. On farm activities, I think we can have a lot more opportunities around autonomous and connected machinery with software, data-rich environments, data-driven business models, adaptive data collecting and processing, relevant and secure data. And obviously all of this is basically setting up a system where you have more quality, more reliability, more accuracy, and more security. So if you think about our farmers, they do have a lot to do. Okay, when you think about there is feed, nutrition, veterinarian stuff, you know, consultants. Then they have to be worried about the weather patterns, regulations, government, media. All of this type of stuff is something that a farmer has to worry about. Now, there is supports available to assist them with that, but it's a huge amount to do for one particular individual. So I think that's where disruptors need to come in. So if you think about the world's largest taxi company owns no taxis, the largest accommodation provider globally owns no real estate, the most valuable retailer has no inventory, etc., etc. So there is disruptors out there. And I suppose the question is, what will agriculture look like in the next 2 years, 10 years, 20 years? And I think that's where the technology advancements come in. So farms are growing bigger. We need for more technology. I think this would be about 10 major technologies that I think exist currently with the power to transform or disrupt agriculture. And each of these areas have the ability to do what we need, produce more food, produce it sustainably. But I think underpinning all of this activity is artificial intelligence. That will be the driver of how all of these pieces of technology intertwine and develop in the next couple of years. And all of that, so I think from those technology trends, taking climate change into account, which is so important, like when you go to the wildfires that we've had, like situations in California where there has been record temperatures, you can't grow grapes there anymore. How are you going to produce a massive production of wines that cannot be grown there because of the temperatures getting so high? Growing world population and obviously food security. And I think all of these areas are driving the adoption of the technologies that we need to solve the problems that we're facing. You know, we have low-cost, high-performance sensors that can collect vast amounts of data. That data can be used to provide farmers with assistive technologies that will be of benefit to processors, consumers, and obviously the environment. And then there's huge breakthroughs around nutrition, genetics, you know, satellite imaging, a massive opportunity for agricultural technologies, you know, for future and potential development in these areas. Trends, I think, to be fair, there is a lot over the last number of years around using GPS and mobile applications, and that is an advantage. There's big trends around using drones for surveying, and I think this is all very positive. Being able to identify individual cows, for example, through RFID identification, looking at nutrition, all of that is of massive benefit. And when you have the ability to identify an individual animal, obviously you have the ability then to improve that nutrition, increase production at an individualized basis rather than looking at a whole herd per se, which obviously has an impact when you are trying to improve your overall productivity and production. I think from an AI perspective, there's 3 major categories in agriculture that really can benefit and develop from AI. I think agricultural robotics, crop and soil maintenance, and predictive analytics. So from a robotic, I suppose, agricultural robotics, you can see where you can have automated robots that would look at breeding, looking at disease, looking at automated milking, looking at automated cattle drafting or whatever else needed to be done. There's massive opportunities there. Obviously, you don't want, you know, a farmer, because of the shortage of human labor, to be involved in, you know, crop and soil monitoring. So automated systems driven by artificial intelligence can only be of benefit there. And certainly this is where I think that the first speaker, Colleen, mentioned, you know, her particular work in this particular area. And obviously around predictive analytics, particularly with, I think, weather cycles and climate change, you have to be able to look at trends and be able to use those trends to identify when is the right time to harvest, etc. Because this is going to be increasingly important with varying climate patterns in the next 20, 30 years. All of this relates to what we want to try to do, the ability to grow sustainably. And I think, you know, sensors make sense. We should be putting sensors wherever possibly we can. Obviously, that will lead to huge amounts of data being collected. That data should be interrogated, and then you're connecting devices, that connected world, Internet of Things. And all of this will come back to the ability to provide data analytics on an individual basis that will allow that individualization, which is what we see with Netflix or Amazon, these disruptors where you can now, you know, view your own content rather than actually having some type of content that is provided for you. So maybe just a few examples of projects or products that are currently in the market. And we work very closely with Dairy Master, so it's a nice example that I always like to give. This would be a product that Dairy Master have called the Moo Monitor Plus system. It's a collar that the cows wear. Data is collected, data is transferred, data is analyzed, and then data is visualized. And if you look, there's 3 million data points per day that is collected from the collar around the cow's neck. That data is then analyzed, some of it on the edge, some of it up in the cloud. And then you can look at behavior analysis for that individual animal. Resting, activity, feeding, rumination, if the cow is in distress. All of this can be detected on an individual basis. Like when you think about how difficult that would have been in the past for a farmer to do. And obviously then you're providing information on an individual basis per cow about how the cow is performing and how you can tweak and improve and refine that particular system. Current projects that we're doing, this was one that we did in collaboration with Dairy Master, a LERO project. LERO is the Irish Software Research Centre. It's an SFI funded centre. And what we did was we looked at a vision system and we were looking at one-shot learning, looking at body conditioning scoring of the cow. So being able to look at how the cow was performing from a nutrition perspective and also looking at lameness. So with that vision system, you're now looking at if the cow has, I suppose, the body conditioning scoring is like our own BMI. What you can do then is improve the nutrition that is actually being put into that particular cow to improve production. And also as a result of the vision system, you're looking at lameness. So looking at the gait analysis of the cow coming into the milking parlour. And if there is an issue with gait, you can identify lameness and hopefully intervene and treat that problem before it becomes a serious issue. This is a project that our colleagues in NUIG are doing with McHale's, and it's called Bale Drive Plus. And what this is doing, it's predicting the time remaining in the field, the machine crop and performance, and obviously turning that information that's incorporated into the McHale's baler into information that the farmer can use, the contractor can use, and the manufacturer can use. I suppose another thing that we're doing is that because of having the ability to use immersive technologies for training, in the Kerry campus, as I already said, we have a virtual reality suite. And I suppose this allows us to create content that can be used for training, servicing of particular types of equipment, machinery, or even type, I suppose, farmers and beyond. And I suppose this allows then, immersive content allows you to provide that service or training anywhere in the world. So an issue that one of the companies that we would normally work with is that, you know, it's fine that you can stand over servicing maybe a machine or a milking parlour that is locally to you, locally within Kerry or within Munster. But if you're after selling one of those products to New Zealand, how do you ensure that the customer gets the same customer experience? Well, it's using these type of immersive technologies that you can ensure that if you sell a piece of equipment, that it will give the customer the same experience as you would if it was a local customer. And using then those type of trends to look at predictive maintenance and repair that machines are not down for as long as a result of predictive maintenance, etc. So I suppose from an AI perspective, I think agriculture has to grow sustainably. We are facing a very, I suppose, critical time in the next 20 or 30 years. With climate change, I think with food production, with the growing world population, we have to look at technologies to allow us to produce more. We certainly will have to produce more using less energy, less water. These are all the trends that are going to be there. And I suppose it is the technologies underpinned by artificial intelligence that will allow us to grow and develop sustainably. And I suppose really what we'd say here is that which direction for the fourth revolution for the fourth agricultural revolution, there's numerous directions, there's numerous technologies, but we have to do it sustainably. And we obviously have to do it taking our climate into account. So I think in 10 years, 20 years, or 2 years, because of the disruptors we have there, what would it look like? It's going to be a massive, it's going to be hugely of interest and a real challenge, but I think it's going to be an exciting time. Okay, so thank you all.
Hello, Joe. That was really good. Anybody, any questions for Joe before we break? That's 2 questions straight away. Eamon Galvin from Northern Carbon.
Yeah, a question on look at the different environmental impact of food, particularly, for example, the animal-based, in particular meat, plant-based. Do you see any likely changes on the consumer demand side that are going to occur to potentially have an impact on the shape of the agricultural production as we go forward?
Well, I suppose, are we seeing it? At the moment, I don't think so. There's still going to be a requirement for protein, and I still think there's going to be a requirement for plant-based. And if you look at, we'll say, the United Nations would have predictions that we need 70% increase in both. Whether that will change in the coming years, where it may go to more plant-based, but I wouldn't make a call on it, because I think protein is very important, and particularly for, as I said, for countries that are growing and developing, they want more protein. That happens when you become more affluent.
There's another question behind there, yeah.
Thanks for the presentation. Just very informative. I really like the fact that you talk about even conferences like that. My question to you is just the smallest Irish context about the big players. I guess how we can integrate the small argument on the journey. Well, because all of this is nice and sexy. And yeah, it's a human journey here, really, we had from an ag tech perspective. I see some successes because he talked about DLT and shared data, right? So technically, clusters, small farmers, and getting them playing some open source for some of them, well, could be very beneficial.
Yeah. I think younger farmers, have adopted to more digitization more favorably. Obviously not to the extent we need, but I think there is a challenge, but it is up to our own state agencies like Teagasc and like the universities to ensure that we get out and we try to, promote the benefits of, using, I suppose, data, becoming more, I suppose, digitally competent, and with all of those, that you will increase your production. And I think it will be a challenge, but I think we're hoping that it is the younger generation of farmers that will now adopt these technologies. I think will have to be done.
Great, thank you. There's a question, I think, online, so we're about to unmute there online if you want to ask the question. I don't have your name. Yeah.
Oh, sorry. I think it's already been answered, actually.
Oh, has it? Okay. Okay. Good.
Thanks.
Any further questions before we go for the break? As well, one of the questions I had, Joe, maybe it's been answered by the other ones, but we hear a lot in the news about farmers having to reduce herd sizes and stuff like that. And I'm just wondering, what can AI do to help with that, like, or whatever? Like, I mean, even this morning, I think there was something on the news about carbon emissions and, the wind that comes from animals and stuff like that. Is there anything that can be done there, you think, with AI to help that?
I think well, look, it probably goes back to the uneven production between different types of countries. To be fair, Ireland would pride itself that we would be very efficient in our green-based system in producing milk, for example. I think AI intertwined into all the technology trends can be of huge benefit. I think reducing herd sizes, it may be something we need to look at, but then you go back to, that uneven production across the globe. You better off to go to, production systems that are, I think, very environment and more efficient. And maybe that's the way that you go. AI will have, I think, a huge input into maybe going into countries that don't have particularly good, optimum and efficient ways of producing food. So from an Irish perspective, I think we just need to wait and see, adopt all the technologies and maximize the production that we can do within legislation.
Yeah, go ahead.
I've got a question.
This is Lark. Do you want to call out your name, Lark?
Yes,
Yeah.
Larkin there. There's been any advances around formalizing carbon futures. I'm thinking specifically about Indigo Ag, which offers carbon credits to broadacre farmers in less framework in this country broadly. And this is, by the way, working out the sequestration rate of a particular field is something that does require AI in parts, and also, of course, requires a blockchain ledger to store the fact that this assessment is done.
Just before you ask, could you just for people online, because they're not fully hearing us, could you just summarize what the question is, if you can, before you answer it?
I think, is there any detailed trials or experiments going into looking at soils for do you want to elaborate a little bit more?
There's a couple of companies I know that are looking at sequestration rates of soils, and they're doing image analysis as part of that. They're also looking at topology and all of the usual things they would assess. But what I'm wondering about specifically is if there's any frameworks that are coming along that would enable farmers sell carbon futures based on their soil activity.
I think, right, the only example that I would have, SFI have funded a massive project called Consus, and it's been run out of UCD, and what they're actually doing is looking at a national map of soil and all of its properties. And I suppose the results of that study then would feed into particular types of frameworks that would be required. I suppose that would be, would lead to obviously very beneficial opportunities using, we'll say, technologies like AI. But that Consus project is looking at that particular area.
Okay. Any final question before we break? Okay, so I suppose at this stage we're going to break here for some tea and coffee and refreshments and stretch and bathroom breaks and things like that for 20 minutes. For online, encourage the same. Get out, stretch, take advantage of the sunshine. But please come back because at 3:30 we're in for a great treat. We have Anthony O'Callaghan, the Chief Information Officer, and Sarah O'Neill, the Chief Strategy Officer with Carberry. Again, as we said, giving real life examples of how they're applying AI to a couple of their productions and the smart manufacturing within the Carberry Group, which is a very successful agri-tech company here in Ireland. So please come back to us at 3:20 and we'll take a break for 20 minutes. Okay, thank you. 3:30, sorry.
Hi, Anthony. Be back in 2 minutes. We're just waiting for people to come back from break.
No issue, no problem at all.
Right, thanks.
I'm getting a little bit of an echo, Garrod.
Someone in the room, that's okay.
Okay, no issue, no issue.
Okay, so we'll kick back on again. Hi, Anthony. Can you hear us okay? Everything's good on your side?
Yeah, sure can.
Down in West
Brilliant.
Park. Good to see you. I see the sun is shining down there as well. I can see it coming through the back of the window there, yeah?
Yeah, absolutely, absolutely.
Okay,
Finally,
sorry we're running
finally.
a few minutes late. The challenge is when you break for tea and coffee, it's hard to, the conversations and the networking is so good, it's hard to get everybody back.
That's no
For
problem.
the people in the room and the people online, we have Anthony O'Callaghan here, who's the Chief Information Officer at the Carberry Group. And Anthony's going to talk about the topic of the use of AI and enhanced data analytics across the dairy supply chain. So AI has the potential to revolutionize the agri-food industry, enabling more sustainable farming practices, enhancing efficiency and transforming customer experiences. The presentation from Anthony will give a snapshot of the current application of AI and data analytics at Farm Zero C, our climate neutral, economically viable model dairy farm. And then Anthony's going to talk about some other elements of AI as well. Anthony's been a great supporter of the RDI Hub through his time with the ITA Cork, which is now the Tech Industry Alliance. He was chairman and he's now on the executive director. So I want to thank you for that. And really looking forward to listening to Anthony for the next maybe 20 minutes, and then we'll have 10 minutes for Q&A as well. So I'll hand over to you, Anthony. We have about 60 people online, and we'll have about 20 people here in the room as well. Okay?
Oh, that's super. Thanks, Liam. And you guys can hear me okay?
We can hear you good, yeah.
Fantastic.
Good, yeah.
Okay, thank you. So afternoon, everybody. My name is Anthony O'Callaghan, and as Liam said, I'm the Group Chief Information Officer for the Carberry Group. Sarah O'Neill from our side, she's the Global Strategy Lead. She was due to be here today, but something popped up at the last minute, so unfortunately you're stuck with me. And I'll do my best to kind of talk through some of the content that Sarah and I had aligned on. So for those of you who don't know Carberry, we're an international dairy, nutrition and flavour company, and we're headquartered here in Ballineen in West Cork. But we have operations all around the world. So outside of Ballineen, we have 12 locations all around the world across Asia, Europe and North and South America. And we have a little close to 1,000 employees. So my own role, I suppose I came on board with Carberry in early 2020, just before the pandemic hit. And we've been on a fairly extensive digital journey since then, right? So I suppose I just wanted to kind of take you through today how we are digitizing across the organization and also what's in our scope. for the years ahead, right? As Liam said at the start, right, we're going to briefly take you through some of the aspects of Farm Zero C, how we're digitizing within our four walls, etc. But most importantly, I wanted to kind of take you through how we are approaching it from a mindset and culture perspective as well, right? Because there is a huge shift across the mindset and culture when it comes to digitalization, right? So I wanted to start off and share a slide with you, which is, I thought was very relevant for the discussion today, right? So this is the latest hype cycle from Gartner related to AI. And, as I said, because this is an AI discussion today, I thought it was very valid and very timely because you can see here from the hype cycle, Gen AI, which, is probably the most widely discussed AI technology at the moment, is passing through this point of peak inflated expectations, right? Which I think is absolutely accurate, based on what we're feeling in the industry and, what we're seeing across the employee base. So, I've worked in, and actually this hype cycle is just published as of August, right? So you can see that down the bottom right-hand corner, right? So, I've worked in technology, I'd say about 25 years now. And throughout those 25 years, I've seen, various kind of hype cycles, right? And look, a hype cycle is a hype cycle. It always follows the same curve, right? But throughout those 25 years, we've had various from a technology perspective. We've had the cloud hype cycle. We've had digital workplace. We've had IoT. We've had blockchain. We've had cyber and many more, right? And now what we're looking into is this AI hype cycle. But, I can honestly say, throughout all of those hype cycles, this is the one that I believe is the most exciting, right? And this is the one that I really believe levels the playing field for a lot of organizations as well. And what I mean by that is that if you go back to maybe the 2000s or the 2010s, et cetera, when we had hype cycles like cloud, et cetera, to take on a digital transformation in those times, you needed to have deep pockets. And those deep pockets bought technology that gave you a competitive edge. Today, when we're looking at AI, that's no longer the case. I mean, some of this technology does cost a lot of money, but in the majority of cases, the barrier of entry for these technologies is so low that that financial barrier has been largely removed. And you're seeing a lot of small to medium companies now able to compete with the large Fortune 100 companies because they all have access to the same amount of tech. Now what we're seeing is that the distinguishing factor or the success factor involved in implementing some of this tech is the ability for the organization to move as fast as the technology can. I think what we're also seeing here in this hype cycle is, as I said, is very representative of what I'm seeing in the industry at the moment, right? And if you kind of think back to, I suppose ChatGPT, right, as the most widely discussed Gen AI platform out there at the moment, right? This isn't as widely talked about at the moment. It's not making the 9 o'clock news anymore, right? Like it was maybe six months ago. And this for me is a good thing, right? Because this technology isn't going away, but it gives, organizations like ours the necessary breathing room to separate the inflated expectations of this technology from the real value add use case of the technology. And I'll give you an example of this that kind of really stuck with me, right? So I was at a conference 6 months ago, and at the conference there was a panel discussion around the use of Gen AI, and they had some really experienced and successful panelists sitting in on that panel discussion, right? And one of the topics popped up on the panel discussion that somebody had used ChatGPT in the last 2 weeks to write a thesis. And the response that I got from ChatGPT at the time was garbage. So they used that use case to say that, look, Gen AI isn't there yet, so we'll come back and we'll look at it in 2 years' time. And that kind of really struck me because, like, our approach would be very, very different, right? It's not about looking at the limitations of ChatGPT and writing it off. We should be looking at how these technologies can be applied now. Because they will get better over time. And we've seen the leaps and bounds between GPT-3 and GPT-4 in a space of months, right? And we'll continue to see this aggressive kind of trajectory from these technologies. So moving on from that, and you see some of my slides are quite sparse on content. They're probably more talking slides. But this slide is kind of really reflecting the need to think digitally and organizations needing to shift to really think digitally, right? So it's my own view that in order for organizations to excel digitally today, we need to stop thinking about digital as a sole department responsibility. And what I mean by that is that a lot of organizations, when they think about digital, they think about it as the responsibility of the IT department. And I believe that they need to shift that thinking to think about digital as a core competency across the organization, one that will deliver a real competitive edge, but most importantly, one that the entire organization is responsible for. And then on the flip side of that, I also believe that IT organizations need to stop thinking about themselves as separate entities, right? And certainly need to stop using the term, which I absolutely despise, which is, IT in the business. We hear this all the time. We hear this probably in your own organizations, right? That it's constantly discussed as IT and a separate entity of the business. Within Carberry, IT, we refer to that as digital across the organization, right? And for us, digital is absolutely part of the business. It's not separate. So I think there's a mindset shift required there as well. I suppose we can all recognize that transitioning an organization to kind of think differently is a real transformative process. And this requires a shift in mindset, in culture, in operations. It's not solely a technology play. And when we're embarking down this road within Carberry, we first start to think about the change story, right? So, and what I mean by this is, how do we articulate to the workforce why digital and why now? So the reasons to me are obvious, but it's important also not to assume that it's obvious to everyone, right? And ensure that we can bring as many people as possible along the road in that journey and get the opportunity as well to address the concerns that they have up front. I think when you think about the change story, right? So the change story can be 1,000 reasons, right? It can be a necessity to remain digital or to remain relevant in a digital era, let's say. It can be around addressing customer expectations. It can be around operational efficiencies. And people are naturally fearful when they hear the word efficiencies, right? But operational efficiencies doesn't necessarily mean head workforce reduction. It means, increasing the value add of employees by freeing them up with intelligent technological solutions to allow them to do their best work. And I hear a lot of organizations kind of talk about best work as well. I think it's important to recognize that organizations need to confirm what best work really means as well, right? So that's all part of our change story. And I think kind of going along with the previous point as well, look, we have to believe that in the future, people are going to want to work in organizations that are innovative, that have a digital first mindset as well, right? That are not going to be focused on the commoditized tasks, that everyone is going to have a value add to the organization as well, right? So employees are going to want to work for organizations that are innovative. I think it's critically important also to not overlook the need for upskilling. And I think this is where a lot of organizations get it wrong. Even if we look at what's happened in the last 12 months alone, right? So employees went out and they took their Christmas break and nobody was talking about AI. And, I can certainly confirm that, we returned back in January and everybody was talking about AI. So it's critically important to ensure that, the workforce is aware of what this is, and that organizations are prepared to invest in training for those people to help them to operate in a digital world as well. But the last piece, as we kind of think about that change story as well, it's important to recognize that for a lot of people, change is exhausting. And quite honestly, with the pace of change that we saw in the first 8 months of this year, right, I'm even adjusting my own approach, right, to try to slow down, right? So to go slower to start, to ensure we have the right foundation in place, right? So that we have the stakeholders bought in, we have the training plans in place, we have the project plans in place, we have the change management plan, etc. Right? And this is all to ensure that we have the right foundation in place so that we can go faster in the end. And I suppose just touching on that foundation for a second, right? So this is a bit of insight into Carberry's digital journey for the last few years. So we break it up into phases. So phase one of our digital journey was largely led by the digital organization. And our focus really during the first phase was making sure that we had the right foundation in place that we could build upon. And we've used the analogy internally, right, that the digital organization is in the gym and we're bulking up and we're getting ready for the next phase, right? So what that practically meant for us was that we were ensuring that our infrastructure was where it needed to be, our cyber posture was where it needed to be, our data was in the right place, our systems where they were pushed to the cloud, et cetera, right? To make sure that everything across people, process, and technology was in the right position for us to take on the next phase of that digital transformation. The next phase of that digital transformation, the next phase of that digital journey, let's say, is really where this mindset shift comes in, right? So this is where the responsibility is no longer borne by a single department. The responsibility shifts to an organization-wide responsibility, and that we all need to start thinking digitally, right? So this is kind of what goes back to the previous slide I had, right, in terms of ownership and responsibility across the organization. The next slide I just briefly want to touch on, right, and I think this is a critically important task as you go through a digital journey. We spend a lot of time separating the fact from the fiction. And as we look at items like emerging tech, and specifically in the space of AI, it's really important to separate the fact from the fiction, right? And if I walk through some examples that we would have discussed, and I know some other organizations discuss amongst their workforce in terms of fact versus fiction when it comes to digitalization, we hear items like, a digital journey or transformation will yield immediate positive results, right? The fact is very different, right? That digital transformation is absolutely a journey, right? And it often takes time to see tangible benefits, right? So it's not just around landing in a new tool. You need to shift in culture, in work practices, in how we're measuring results, et cetera, to really see those tangible benefits. The other mistake that some organizations make is that they assume that one size fits all, and what worked for one company will surely work for another, right? And it's absolutely the fact that every organization is unique, right? And digital strategies need to be tailored to the individual business needs and context, right? And even as a simple example, every company culture is largely different, right? So that culture has a huge impact on the success or failure of a digital transformation. The other one that we work quite a lot on, right, is around a technology first piece of fiction, let's say. So I suppose, there is an assumption out there that digital transformation is solely about implementing the latest technology. And while technology is a key component, successful transformation also involves the culture, process, people, etc., right? But my own view on this internally, right, is as we are looking for gaps in process, in people, in technology, etc., we don't always come in with an emerging tech answer, right? So it's not about it being high tech. It just needs, or the solution doesn't need to be high tech. It just needs to be good tech. And I think this is a critically important piece, right? As organizations are laying out their next 3 and 5 year strategies, right? That those strategies aren't littered with AI everywhere, because I'm sure we all know in the room, right, that the term AI has been somewhat abused over the last 12 months or so, and largely a lot of the conversations or the solutions that we're seeing out there are solutions around data and ML that have been around for a long, long time, right? So it's really important that this that digital transformation isn't always seen as it has to be emerging tech. It just has to be good tech. The other piece, and I think I touched on this earlier, was around that transformation or the adoption of emerging tech is only for large enterprises, and as I said earlier, right, the barriers of entry for this technology now have been massively removed from a financial perspective, right? So what we're actually seeing right now is that a lot of the smaller organizations are having far better success with new emerging tools because they have the agility within the organization to be able to react to them. There's also the piece around the threat to jobs, and that automation and digital transformation will lead to significant job losses. And while transformation will have an impact on jobs, what we're also seeing is that it also creates new opportunities that require upskilling across the organization, right? So it shouldn't just be seen as a threat to jobs. And I think lastly, the other interesting one is that there's a perception out there that digital transformations end, or there's a definitive end to them, right? And for us, the transformation is ongoing. It's an ongoing process, right? And internally, we're even trying to abandon the use of the word transformation, and we call it a journey, because the word transformation suggests that there's an end, which in the world of digitalization there isn't. And you can even see, based on the hype cycles presented at the start of the presentation, that's just the AI hype cycle. There's been 10 prior to that, right? And there'll be 10 after that. And so the digitalization just continues. The other piece I just want to briefly kind of take you through is how we address opportunities within the organization. So, I suppose when we solely look at, and this is purely from an emerging tech perspective, so when we solely look at opportunities for emerging tech within Carberry, we first start with the gaps, right? So these could be process gaps, competitive edge gaps, and we build up a funnel. And as we're building up that funnel, we're also looking for the blind spots, right? So what is emerging tech doing today that we're not even thinking about? And And I'll give you an example of this. So maybe a year ago, organizations weren't talking about sentiment analysis. That's now very feasible from an AI perspective for a lot of organizations, right? So these are some blind spots that organizations don't see at the moment, right? And this is the type of thing that we are looking at. But I think this selection process can be a very tough process. And when I put in the image here of the magpie, it was really just to suggest that you shouldn't get distracted by every shiny thing, right? Because there are a lot of shiny things out there at the moment, right? So for us, it's important that we make our bets early, that we stick to them, but we're also willing to walk away when we see the signs, right? And I think that magpie effect is quite exhausting as well for a lot of organizations, right? That if we are running after the next shiny thing and we're never settling, we're never finishing, we're never bringing anything to a conclusion, we're just constantly in pilot mode, right? So I think it's a dangerous mode to be in, right? So I think it's really important to be very focused. For us then, as we kind of settle on these bets, we would typically drive a pilot program for a period of kind of 2 to 5 months. So these timelines are very achievable now, but in the past they would have been impossible. To say 10 years ago we wanted to do a machine learning pilot in 2 to 4 months, I mean, you would have been crazy, but now it's absolutely impossible. And for us, the purpose of this pilot is really to focus on the fact and fiction. Is to see if the technology can deliver on its promises, but also make it relevant to the workforce so we can see the use case in action. And then I suppose after a successful or unsuccessful pilot, then we're into project planning phase and we're moving it forward. But I wanted to kind of show you one example of this in action within Carberry, right? So a number of years ago, we started off on our intelligent automation journey. And I suppose back then at the time, and had you gone to any conference 5 years ago and they were talking about RPA and robotics, right? The fiction out there was that the robots are going to take our jobs, and there's a lot of fear in the system, right? And that was absolutely the talk at the moment, right? And so what we did was we worked with a small number of teams internally to pilot the technology. So we took a few projects, and the aim was to prove that this wasn't about taking jobs. This was about freeing up employees from important but commoditized tasks so that they could take on more interesting and higher value add work. For us, these pilots were hugely important, right, because they eliminated the concerns within a very short space of time. But they also gave the teams involved insight into the fact that there's a place for automation as an aid in their day-to-day job, right? And it isn't to be feared, it's to be celebrated or embraced. The other interesting thing that we did in our approach, right, was that we humanized the technology, right? We gave the bots names, we gave them email accounts, they appeared at the time on my organization chart, right? And, it further emphasized that these are aids just like any other colleague, right? And, as a side note, actually, we named one of them, Christy Ring, who's undoubtedly the greatest hurler of all time. I couldn't help but throw that in. But, joking aside, this was a very successful pilot for us, right, with emerging tech, as it addressed the process gaps, it addressed the fear, it addressed the need for upskilling, etc., right? And we've ended up in a place right now, a number of years down the road, where the supply or the demand is outstripping the supply, and we now have we now have employees that don't sit in the digital team that are driving these automations themselves, right? So it was a really successful use case for pushing out new emerging tech, addressing the fear, addressing the upskilling, etc., right? But it took time. So for us, it was really important to start slow rather than go big bang. And we saw that by putting the proper foundation in place, we were able to scale much faster had we gone big bang. When we look at an emerging tech application within Carberry, right? So this isn't just about emerging tech, this is about existing and emerging tech, I would say. We're looking across all areas of the supply chain for opportunity. But in more recent years, we're very careful that we don't go too broad and shallow in too many areas. We want to go narrow and deep in certain areas to have the biggest impact. So what I mean by narrow and deep is that we want to keep the focus narrow to certain domains, right? So a domain for us can be a customer journey, it can be waste reduction, it can be product manufacturing. But once we've selected the domain, then we go deep with the application of technology, and we're aiming to digitize as much as we possibly can within this domain. I think, as I said, at the early days, when we look at areas like automation, we went quite broad and shallow, and we were now trying to pull that back in because we wanted to give the organization as much exposure to this emerging technology, and then it allowed us to focus back in a little bit later on, right? But for us, certainly it's around going narrow and deep right now. But for us, it isn't about digitization for the sake of digitization, right? This all goes through a thorough ROI process, et cetera, right? But there are some areas of emerging tech, like you're just going to have to take a bet, right? It's very hard to wrap an ROI use case around something that we don't fully understand yet, right? So in some scenarios, you have to have that entrepreneurial environment or mindset internally to allow people to take risks with some of this emerging tech without risking the house. And I think what this means for us today is that, we've gone deep in back office function with digitization. We're starting on that journey as well with manufacturing, as we create a blueprint for the factory of the future. And the ultimate goal here is to leverage technology to drive our operations in a more efficient and sustainable way. But what this means for us from a technology perspective across the organization, we have IoT technology in place, we have automation technology in place. We've recently brought in elements of Gen AI, et cetera, right? So we are a fairly exploratory organization, right? And we're willing to kind of take these kind of big bets, right? But for us, it's about going across the entire supply chain. And what you're looking at here really is inside our four walls, right? But there's another aspect to this, and Liam alluded to it earlier, right? So the last piece I just want to show you here, and I promise I'm done after this slide, is a project that we at Carberry are very proud of. And what you're looking at here is the overview of our Farm Zero C program. So this is an ambitious program which we're spearheading, which is aiming to create the world's first climate neutral dairy farm, right? So this will be achieved through a combination of sustainable farming practices, but also with the aid of technology. And I'm sure, as you've probably heard from some of the previous speakers today, talking about the application of on-farm technology such as soil sensors, satellite imagery, traceability, CO2 tracking, et cetera, right? All of this is being aided with emerging tech and existing tech, and it's something that we're very proud and excited about, kind of seeing the results from a Farm Zero C perspective, right? So I think this was just a good application of some of the technology that you've heard about today being used within a live farm, and we're currently working through that over the next number of months as well, and hopefully we'll pull some positive results out of those various scenarios. Sorry guys, a screen just popped up here in front of me, my apologies. So I think personally for me the most exciting thing about this, right, is that if Farm Zero C is to be successful, and we're really confident that it will, we'll have created a blueprint that can be applied across the world, right? And this for me is a great example of technology aiding in our sustainability drive globally, right? This is real life, this is something that we can see and we can touch, et cetera, right? But it's a real good example around technology aiding on farm. So that's all I have for today. I think I'm right on time. But hopefully if there's any questions that you guys might have, then I'd be more than willing to hang around and answer them.
Thanks, Anthony. No, that was great. Really good oversight on and how Carberry approaches kind of the digitalization journey and the AI journey. And I suppose one key insight I kind of took from that is the whole culture element. You can all talk about AI and digitalization, but if the culture isn't right within the company to kind of embrace it, it's always going to struggle. It's like what Drucker once said, culture eats strategy for breakfast. You can have the great strategy, but if you don't have the culture. I'll just open up the floor. Anybody online, any questions? Anybody here? I know, Michael, did you say you want to have a question earlier on, or do you want to answer it now? Or?
I guess it's a broad question. It'll touch on some of the stuff Anthony spoke about and stuff that Professor Joe spoke about, and even some of the stuff we heard earlier from California. There's many trends that seem to be leading in the same direction. So AI and sustainability. If we look at new technology, I learned about this earlier that Colleen spoke about, where you're using the aerobic and anaerobic layers of the soil to actually self-power remote sensors, gathering vast amounts of data cheaply that way. Tying that thread together with threads like I'm first late into a master's in data analytics at UCD. We've got one of our visiting professors, Sinead McCarthy. She's in Tegas. She's looking at big data where they look at milk samples, run IR sampling like that. So you've got vast amounts of data there, and you're able to tie that back to what those animals were or what nutrition they were getting.
Absolutely.
Dairy Master, probably out in Cosby, are building similar vast data sets. Extremely useful. So there's an awful lot of leverage to begin, I think, in tying all those things together. So I suppose my question is, it's a general one. Who and where will so who would be best positioned to start up or get funding from, and we heard earlier from our colleagues at Microsoft or our friends at Microsoft, but EU funding. Somebody with a good idea wants to get into this area. Are they best placed in an industry and commercial collaboration environment, or is it more pure science? Is it more a creative commons area where people take forward these ideas? It's quite a general question. It's probably for both those speakers.
Yeah. So I don't know, Anthony, did you fully hear the question? But it's more
I
around.
literally, yeah, I just got the back end of it. But
I suppose just to summarise it, because I know some of the people online may not, but I suppose Michael's question, hopefully I'm summarising correctly, Michael, is if you have a really innovative idea for an AI startup in the agri-tech space, like what's the best way to approach it? Like, is it going into an academic environment? Is it going into an industry environment? Is it collaborating with a research centre like ourselves? Or what's the best way to to bring it forward? And Joe, you might have your own thoughts on it as well. But I'll let you talk first, Anthony, in terms of what you'd advise somebody with an innovative startup idea in the agri-tech space.
Yeah, I think that we probably wouldn't be best placed to answer that. Look, I know we've collaborated even through Farm Zero C, right? We're collaborating with a number of startups in that program as well, right? You know, from a carbon capture or carbon calculation perspective, we're working with some startups in that space, right? So, but we've had multiple routes in terms of identifying startups or allowing startups to maybe come into us and pitch ideas, etc. Right? So either it's via an Enterprise Ireland type arrangement, it's via the academic route as well, right? I suppose for us there's been multiple routes into Carberry, and look, we're always willing to discuss a really good idea. There was actually an organisation that we're part of at the moment that brings essentially 20 to 50 startups to a company like Carberry to pitch an idea to Carberry to solve a specific problem. Now the name escapes me, but that was a really innovative approach, right? Because the way that worked was that they gave companies like Carberry, and I think Glanbia were involved in it as well, right, the opportunity to come and pitch their business and pitch some of the pain points that they might have across manufacturing, milk intake, etc., and give the startups a number of weeks to go back and kind of think through that use case and see how they could apply their technology to the company, right? So I can dig that out, Liam, and I can send that to you. And you know, you can absolutely circulate it to any of the guys there that might need it. But that for us was a really good engagement model because it allowed them to talk about a specific problem that we had highlighted and see how their technology could be applied to it. So it was nearly short-circuiting the buying process.
Great, thanks, Anthony. I know, Joe, do you want to comment on it a little bit?
Certainly it's been a better time to be able to support to commercialise an idea and to develop startups. So from an Enterprise Ireland perspective, you know, there is support around New Frontiers, accelerator programs. From an academic perspective, Enterprise Ireland commercialisation funds, where you're remaining in academia and I suppose you develop and commercialise your idea. You do a feasibility study where you do some market research as part of that. But there is fantastic support. And SFI, I suppose, Zero Farm Seed would be an SFI challenge project originally. So SFI have really branched into offering challenges to academics around particular areas and then coming up with solutions for those challenges. So it is a great time, and certainly look, if UCD perspective, we would do a lot of work with UCD, and if there was an idea that you had, we'd certainly be interested in helping you out with that.
That's great. Thanks very much.
Okay, great. Just for the people online, if you didn't fully summarise Joe's feedback, I think he was saying it's the best time ever to have an agri-tech startup. But in terms of all the support that's out there, whether it's from Enterprise Ireland, Science Foundation Ireland, you know, I suppose in UCD, you've Nova UCD, there's the Agri-Tech Centre of Excellence here in Munster Technological University as well. So if you have an idea, and look, we're here to support as well within the RDI Hub. So look, Anthony, we won't keep you any longer. It's a warm day. I'm sure you want to, like everybody, get out and enjoy the sunshine while it's there. Thanks a million for the insights. It's really, really good. And we will remember that Cork plug you put in there as well about Christy Ring, you know. I actually thought Mike was going to ask you a Limerick hurling question there, but he didn't. Yeah. All right, listen, thanks, Anthony. We'll let you go.
Great.
Appreciate it.
Thank you so much. Thank you. Cheers.
Okay, so we're moving from West Cork to, is it Sri Lanka? Is where Suma is based? Where? Beijing. Suma, can you hear us okay? Hi, Suma, there you are. Good to see you. So welcome. Welcome. We won't ask you what the temperature is in Beijing, because you're probably pretty hot is over there, I would imagine, as well. But we're definitely up on 27, 28 degrees here in Ireland today, which is great. So look, welcome to the AI Summer School, and the Assistant Professor Suma Dev is going to talk about remote sensing for climate, air quality and weather prediction. In the age of advanced technology, remote sensing has emerged as a powerful tool that revolutionises our understanding of the natural world This talk will delve into the pivotal role of remote sensing in assessing and addressing critical environmental challenges, from monitoring climate patterns, engaging air quality, to enhancing the precision of weather prediction models. Remote sensing techniques offer unparalleled insights into the complex interplay between Earth's systems. So we're looking forward to hearing your talk about cutting-edge satellite imagery, sensor networks, and data analytics that are reshaping the way we perceive, predict, and respond to the intricate dynamics of our changing planet. And just so everybody knows, this talk is brought to you in association with the ADAPT Research Centre, which is one of our partners in the summer school. So Suma, we'll hand over to you to present maybe for 15-20 minutes, and then we'll have some questions.
Perfect. Can everybody see my screen well?
Yeah, we can see your screen and we can hear you good.
Perfect. Perfect. Let me start. So good evening, everyone. Good evening from Beijing. And first of all, I'm really sorry that I couldn't be in person and talk to you over there. But nevertheless, I'm very happy and excited to be a part of the summer school. And as Liam was mentioning that, we will be talking about how, in our group, how we have used computer science techniques in understanding most of the events in the atmosphere. So over the last decade, we have been working in our group where we have been using machine learning techniques and computer vision techniques to understand how we can, understand the Earth observations better. So, trying to utilize some of the techniques that are popularly used and solve some of the problems in atmospheric science. So this has been quite an interesting area for several decades, but I would say for the last 1 decade, things have really, sped up, mainly because of the idea of open source data sets that are being published online by several research groups, and also, with the advancement of the computing power. So there are several techniques in which our group have been working on, mostly on trying to understand the data well, because data is absolutely diverse. So there are several, there are several, data, for example, satellite images, ground-based images, and other weather station data. So in our research group, what we have been working on is to use these images and trying to predict some of the atmospheric patterns. So as you can see over the slide here, satellite images are actually quite good because they are publicly available, and you can find satellite images of absolutely all places of the Earth. However, the main problem with the satellite images is that they have very low spatial resolution and low temporal resolution. So what we have been doing in our group, that we have actually built some of the sky cameras or ground-based cameras that kind of looks up into the sky and takes pictures every few minutes. Now this is really interesting because that gives us a more of a localized information, and we have got good spatial resolution and good temporal resolution. So in this brief talk, what I will be talking on are mainly 3 pillars, and I will be discussing how we have been trying to really push the boundaries of research by using some of the state-of-the-art techniques. So first thing, the first pillar that I will be working on, and I will be discussing with all of you, is on coastal monitoring. So why do we have to monitor the Irish coastline, specifically here in Ireland? Now, as most of you might be knowing that, Republic of Ireland has got an extensive coastline around 3,000 kilometers. And this project was in collaboration with Geological Survey of Ireland. And what we have understood by talking to them is that it is really difficult for them to actually manually identify and map the coastlines properly using manual annotation tools. So there was a pain point in trying to understand, can we automate this whole process? Can we develop some approaches in order to identify the coastline better, so that actually we can monitor how the coastline has changed over the last few decades, by the way. So what we have been working on over the last 2 years is to see this problem as kind of an edge detection problem. So people who have been working in computer vision understand that this is quite a fundamental problem in computer science. So for example, we have got an RGB image, the regular red, green, blue image, and this is one of the reference image, the one which is handcrafted and which is actually marked by hand. So we have been trying to see, can we use the edge detection techniques in computer vision to identify this particular edges properly. And more, I won't go into the details of it, but as you can see, we have tried several edge detection problems, edge detection methods, for example, Canny, Sobel, Shar, and Previtt, and we realized that techniques like Canny can actually produce very good results while compared to the ground truth images. So this is pure computer vision applied directly to satellite images. We then move forward and try to see if some of the state-of-the-art deep networks can also be used in order to understand the land and water segmentation. So this has been really fascinating for us, and we kind of delved further. And we realized that the satellite images that we get over any particular place, they are multispectral. So essentially, it means that in the conventional images that we all know are red, green, blue. So however, satellite images give information more than that. So we have got the near infrared images and several water indices, water channels that we can also understand. So this is the one, the red, green, blue channel, which we know in day-to-day life. This is the ground truth mask, which is actually manually annotated. This is the near infrared images, and these are the several other water channels, by the way. So, as I come from academia, so we try to question everything, and we try to understand, like, we know there are several plethora of channels, but which band are actually useful to understand the land and water? And even if we try to find out which channels are useful, how do we report it to the policymakers to understand that this is actually my best performing models? So we have been, trying to work on this. However, it's interesting to note here that, we do not have any data set for the Republic of Ireland. So the images that you see over here is actually from a city in in one of the European countries, which is publicly available, and we have been trying to build our techniques on that. So in order to understand, which bands are useful, most details are there in the references that I have shown here. But just to give you an idea how we have been working on that area. So for example, this is the near infrared image that you see on the left hand side of your screen. And what we do, we kind of permute the pixels in the image. So essentially, we just kind of randomly arrange the pixels of these near infrared images, and then try to use computer vision techniques to find the detection of water and the land from both the near infrared images and also the permuted images. And based on the difference of the score, we can actually find out which of the particular channels are absolutely useful in order to detect the water. And it's, as you can see clearly, that some of the water indices are good, and some of the near infrared images are also good, while the visible light is not very good images. So as I come from academia, we have been trying to go deeper and trying to really tease out these details. But from the perspective of GSI, like, why do we really need to do that? And essentially, what the reason for on this area and trying to understand which bands are useful is to build trust with the non-technical stakeholders to see which of the channels do we really have to monitor instead of monitoring all the channels. And potentially, we can actually find out new spectral indices based on water vapor that we have really found out. So these results are really fascinating for us. And what we have been working on currently is to see, can we actually release the first Irish coastline data set that will be released to the research community. And I think this will be this is very exciting for us. We have been working on that, and the work is currently under review, where we have actually manually annotated a huge library of Landsat images. So Landsat is a kind of a satellite images that are done for the east coast of Ireland, and for the period of 40 years. And we are really interested to see how the research community accepts it, and that will be the first Irish coastline data set to be available publicly. moving on to the next thing, we have seen how we understand the coastal monitoring using computer vision, but the idea here is that most of the techniques can also be used in other atmospheric events, for example, to understand air pollutants. Now, as you know over here that like we don't really have to see the introduction over here, because the air pollution is a problem, possibly not much in Ireland, but for example here in Beijing, where I'm currently based in, there is a huge population, there is a huge pollution problem, and it causes several health issues. So can we actually use some of the historical data points to understand and predict the air pollutants? So what we have been working on, this is in collaboration with our university here based in Beijing, where we actually selected some of the cities in China, and we developed a bidirectional LSTM by GRU model in order to predict the particulate matter concentration, so the PM 2.5 concentration that's available in the atmosphere. So the main idea behind this is that we use historical air pollutant data together with other weather data, for example, the sunshine, cloud cover, the sun rays, and then we fuse them together into a bi-LSTM model, which kind of extracts the shallow features, and then the subsequent bi-GRU models extract the deep features in order to predict the air pollutant for several lead times. So essentially, if we have historical air pollutant data and the weather data, we can actually predict with confidence what exactly will be my PM 2.5 concentration in the next few hours. So, just to give you an idea of what we have been doing, so we realized that, we could actually perform really well up to 180 hours in advance. We have the kind of the state-of-the-art evaluation metrics in understanding the PM 2.5 concentration in advance. So we, kind of benchmark and calculated with respect to the other models that are mostly available in the literature, and we realized that our bi-LSTM bi-GRU really works well. So this was very fascinating for us because, that kind of really opens up the idea of using the deep network, which we have been using in other techniques, also in this area of atmospheric monitoring. So we moved ahead and we saw, like, can we have similar models apply for other gases in the atmosphere? So perhaps, nitrogen dioxide, carbon monoxide, and we use a similar architecture of using bi-LSTM, bi-GRU on the historical data together with the weather data to see can we predict well. And it's surprising for us to see that we really performed well with respect to the other methods. We plot the RMSE score, which is essentially the error metric. So essentially, if we have got low RMSE, we are performing well. And if we have higher RMSE, it's not very well. So, up to 180 hours, we actually plotted the red one is our proposed architecture, the NES deep net, and we realized both for nitrogen dioxide and carbon monoxide, we have been performing well, and we could actually predict those concentration in advance. So what's next, and what's our vision in this case? So what we feel in our group is that this is important, and there is absolutely an urgent need for creating an intelligent system for real-time prediction of such atmospheric pollutants. This can be, once we have a robust model, we really can actually use it for other services like real-time pollutant monitoring, decision making, showing some warning message to the users, and also they can check it from their web app or from the mobile app, and they can actually see and have an early warning system of such pollutant concentration. So this was fascinating for us, and we thought of working on this, and we are really hopeful that several other interesting results will come in the next few years as well. Moving on from air pollution, I will now briefly talk about sustainable grid management. This is something very close to my heart because we started working on this atmospheric research, particularly from this area. Now, as you know, there is a huge push in trying to go to renewable energy, mostly from solar energy, so that we have less dependence on the fossil fuels. But this is not an easy problem. And as you know, the main problem here in such solar energy is that it's really difficult to know in advance what will be the solar irradiance. So as you can see over here, the red line that we see is actually the amount of solar irradiance that is observed on a particular position of the Earth. And there is absolutely no pattern. We know that it's the solar irradiance is less in the morning and the evening, but over the entire day, there is a huge sporadic, changes in the solar irradiance. And this is not nice, because we really have to understand this properly in order to integrate it with the conventional grid. And what we have observed that if we can actually see the corresponding ground-based sky camera images that we have been developing and see if the area around the sun is covered by cloud, we know that there is a dip. However, if the 5 minutes below, 5 minutes before and the 5 minutes after, the area around the sun is clear, and we saw that there is a good solar irradiance. So the idea here is that if we can find out whether that particular or at that particular time, if my sun is covered by cloud, there will be a dip here. Otherwise, it's clear. So this was fascinating for us, and over the last decade we have been building several models of sky camera. Essentially the camera which you see over here, which takes pictures of the sky, and the one on the right hand side you see the images that is captured by it. So using these camera images, we can actually sample points around the sun to understand how bright the pixels are around the sun, and project it into a hemisphere and calculate the average brightness of it, and we can estimate the solar irradiance perfectly, and we really can match the entire sporadic changes properly with higher degree of accuracy. So this was interesting for us. This was fascinating. That means using the sky camera can actually help us in estimating it. So we moved ahead. So the next step for us is, when we obtain the solar irradiance, can we also forecast it? So not to go into the detail of this, essentially what we do over here is that we extract the features from the corresponding satellite images using an encoder decoder architecture, and use it along with other solar zenith angle, the solar irradiance, feed it into a layer of LSTM, and finally we can actually perform the GHI, or the global horizon irradiance, essentially how much solar irradiance will be predicted over the next few minutes. And we have been we discovered that we could really predict the output solar irradiance over the next 20 minutes with good accuracy. After 20 minutes, the accuracy drops off really in a really sharp manner. So in 20 to 30 minutes, we could actually perform the prediction really well. And we observed that this can be used as a benchmark. This can be used as a tool for several places to see and integrate such machine learning models, or perhaps the deep learning models, if we have the data to predict.
You're on mute, Suma. You're just on mute. Yeah, no,
All right.
we just lost you there as you went on to your concluding thoughts. So if you want to stop there again.
That's my penultimate slide. So that's about my concluding thoughts, that I feel that computer vision really is essential to understand the coastline changes, and we can actually understand the impact of climate change. AI-powered image analysis can also be used in public health management, as we have seen in our work of air pollution. And finally, the smart grids, which are powered by AI, will enhance the reliability and the sustainability of solar energy systems. So I think if we can merge the the developments in the area of computer science with the remote sensing, I think we will be able to really, really push the boundaries and can have a better life for the entire humanity. So with this, I would like to thank my entire team behind this research. They have been really fantastic, and I really thank all of them. All the research that we have been doing has been really fascinating because of their hard work, and credit to the entire team for this fascinating field of research. So thank you so much for your for your time, and if you have any question, please feel free to give me a shout. Thank you.
Great, thanks, Suma. Fascinating research. Anybody, any questions here in the audience or online? If you have any questions, pop it in online. Just while we wait, I guess I have one question for you. I mean, looking at the research you've done, I mean, what we're trying to get across in the conference as well is kind of an applied element. I mean, have you talked to any industry partners about what you're doing, or where would you see your research applying into industry, or what kind of industry partners would you work with?
So essentially, in the research that we have been showing in the three pillars that I have been talking about, mostly air pollution, the coastal monitoring, and the solar energy. I would say the coastal monitoring is the one where we have interacted with the government agency really well. This is actually all the research is done in collaboration with Geological Survey of Ireland. However, for the other things that we have talking about, mostly on solar energy and air pollution, I think this is still in the nascent area, because there is a lot of progress that still needs to be done in order to have it a kind of a commercial impact. And but we are in touch with organizations like Materian and everyone, so who have been really interested in this kind of research, and they feel that using it in the context of the Ireland, and see if we can actually create a robust platform, that will be fascinating. So so I will say it's still an early stage, but I think we have the knowledge to really work with with a particular organizations, be it a private sector or a public sector, to see if we can actually have, because some of the problems in that which I have results which I've shown here have a huge computational cost. So although the results look good, but they really are not possible to have a kind of real-time implementation. So that's another field of research that we need to do, like to have such a kind of good accuracy, but also compute it at the least possible time. So I'm looking forward to it, and I think we are still going at that pace to see to have this real world implementation quite soon.
Great. Okay. Thanks, Suma. Anybody, any questions before we wrap up? Okay. So thanks, Suma. Really appreciate your insight. Thank you.
Thank you so much.
We kind of said at the start, I mean, we've kind of got a mixture of people joining online, like Suma coming in from Sri Lanka, and then people here in person in the RDI Hub. So now we're moving. The next two sessions will actually be in person in the hub here. So next talk we have is from Daria Vatt, who's the drone engineer at Xenodrone. And also with Daria today is his colleague, Simon Henry, who's the business development manager. So Xenodrone was in the media quite a lot recently. There's some great articles around sustainable farming with AI drones. So this talk will cover the current farming situation, how it's improving with technology, how drones are not only a photography tool, use cases of the drones in agriculture, and how AI and machine learning can be a key revolution in agri-tech. So we heard a lot over the last couple of talks with Professor Joseph Walsh talking about drones. Colleen mentioned it quite a lot as well. So you're actually going to show it in action. You're actually going to realize stuff. So over to you. You've got 20 minutes to present. Oh, you need a clicker, yeah? That would be handy. Just make sure you don't hit the mute one button. So yeah.
Closer to the PC or something.
No, it's me.
Oh, it's me.
Yeah. Yeah, I'll just start with the introduction. Hi everyone. So my name is Darya Bhatt and I'm working in Zenadrone as a accountable manager for the operation and as a drone engineer. We have Simon Henry here, our business development manager. So we are, I'll give you the more information about the company. So back in 2019, our CEO came here in Ireland for doing some hemp monitoring to identify the male and female hemp. And he was using drone at the time, but we know the Irish weather. Sometimes it's windy, sometimes it's not. So he was using third-party drone, and then he got the idea to make something which can be overall solution for the monitoring or the agriculture or any other sector. So then we did lots of research, and then we came out with the Zenadrone 1000. That's our flagship model. So the drone we have, it's completely packed with AI, and it's a 3x2 meter drone, which is 120 kilogram of maximum takeoff mass. It can carry 40 kilograms payload. It has 1 hour of flight time. So I saw in past presentation that there is the limitation in the drone sector, the flight time. So we have 1 hour of flight time, and we also have 1 hour of fast charging, and we have developed the charging pad technology. So I'll talk about the Zenadrone 1000 a little bit. We have AI integration, and the drone is completely customizable. So you can customize the hardware and software according to use cases, according to the industry and industry requirement. We have autonomous flight system. We have stabilized camera, 4K camera, different sensors. You can add, remove different sensors as per the requirement. We have multispectral sensors. So this will expand the limitation that we have currently. So that will give us the free hand using the drone technology, specifically in agriculture or renewable energy or the reforestation. Like all the fields currently using the drone, and they are more focused on using more drone technologies. So it will unlock new capabilities and the new features for us. So we talk about the sustainable agriculture. So what is sustainable agriculture? We all know, but the sustainable agriculture is just that we can use the best non-renewable resources and we can use more of the natural resources. That is the sustainable agriculture. So with the help of AI and with the help of AI-powered drones and the machine learning, we can actually expand our capabilities in the sustainable agriculture. So by that, we can enhancing the soil health monitoring system. We can also reduce the water and air pollution. And the key part currently, there are lots of articles and blogs about that one, that the pesticides uses in the agriculture sector. So we have developed the technology with the help of AI and database and data analyzing and the machine learning, that the drone will scan the particular fields, and then it will find out with the help of AI and the data collection, it will find out the particular spots, and then it will do the spot spraying. So basically, this will also give us the good advantage in reducing the pesticides use. So that is the key and the very big feature in the Zenadrone 1000. The drone is completely autonomous. So basically, it will reduce the reliability on the manual controls. You can program the flight and the drone will automatically do the operations. As I said, that it has 1 hour of flight time. So basically, before the flight, it will give, we just need to set the path. Operator needs to set the path and it will go do the operation. And in the meantime, it will detect the battery remaining and it will come back. We have the charging pad. So drone will land on the charging pad, get charged, and it will finish the remaining tasks if it's required. So that's also saving time for any inspection or any monitoring the field or any operations for spraying or seeding. So, so this is the primary use for the drone. We can also do the crop health assessment. Then we can also do the crop monitoring, aerial pesticide spraying that I'm saying. We have two systems, spot spraying and the white spraying. So we can do accordingly operations. We can use the drone as it has lifting capabilities of 40 kilograms. So we have the different attachments. So we can use the drone as a seeder to do the seeding, as well as we can use the same drone for the reforestation. That is also one of the key things. Currently, we are having wildfires and all the stuff. So we require the reforestation, and there are lots of organization doing the reforestation right now. With the help of AI and the machine learning, drone will give us the visual data, drone will give us the wind speed data, thermal data, and photometric measurement data it will provide us. As I said that, it will give us the free hand in the because of the long lasting battery life, it will give us the more capability time to do the operation and do the other thing. We have the VTOL flight mode, so it is easy to operate. We have 4K cameras. As I said, it is customizable, so we can remove the sensors and the cameras as per the requirements. And we have octocopter drone, so basically it will provide us good lift as well as more stability. We have multispectral sensors, so we saw in one of the presentation that we can get the RGB data, RGB imagery, and by that we can check the soil health as well as we can gather more data for the farming. With the help of AI and with the help of data, we can have all the cloud-based data on our tablet or mobile phone or web-based software that we have developed. We have developed the software in-house, so by that we can also use most out of it. We can see that the plant health parameters, then the crop heights. So basically, we can say that from the seeding to the store, we can check all the data. We can do all the analyzing, and this is only possible because of the AI implementing in the drone. So as we are talking about the sustainable agriculture, there is other sector as well, ranching and the livestock management. So with the help of drone, currently there are lots of farmers using drones just to keep an eye on the livestock in the big fields. But we have different sensors. So with the help of that, we can also check the health of the livestock. We can also track them. We can also early detect the disease in the livestock. And basically, we can also enhance the livestock management by that one. With the help of AI and the smart farming and the cloud-based technology, we can analyze the data and then we can make our farming smart. And by that one, as I said, it is autonomous drone, so it requires less people and it requires less time. So it will also reduce the dependency on the manual controls and manual operations. So this was all about the Xenodrone operations and the AI. And so as we know that Ireland is more advanced in the farming right now, and it's keep growing. So we are also launching drone as a service in Ireland. So basically, instead of buying the whole drone, a cluster of farmers can come together and rent the drone. We are launching drone as a service model for renting and the leasing. So it will be more helpful, and it will also give them it will also save them from approvals and all the process. Currently, we are in process for the approval with Irish Aviations. So hopefully in few months, we're gonna start doing demos here in Ireland itself. So that was the Xenodrone and AI drone. So if you have any questions.
Thanks, Daria. Simon, is there anything you want to add, or are you happy enough? Everything's covered there, yeah? Yeah. No, I just want to be sure that if there's anything extra you want to add. Anybody, any questions on fascinating drone technology? I'm really interested in how you rent one, especially from the audience. Is there a question from the audience? If you can unmute.
I want to ask a question, but somebody already, I think Michael already asked it in the chat. What is the cost of the drone?
So currently the cost of the drone, which comes as a basic sensors, cameras, and all of the stuff, is 75K euros, and it comes with the charging pad. So basically, it's come with the charging station, which includes 4 batteries. Drone will power with the 4 batteries, as well as all the basic cameras and sensors that we talked about. And yeah, that's the basic. But we have different models, and as I said, it is customizable one. So we can also add remove sensor as per the industry requirement.
Thank you.
Go ahead, Eamon, yeah.
Yeah, I think you mentioned the 40 kilo kilos, but have you seen any, like, where it's been a cost advantage for the farmers use it to do certain tasks? First question. Second, does it have to be the farmer that uses it, or can people use it? Because it almost looks like a games control. Is it opportunities for other people to do some of the tasks that the farmer normally do, for example?
So just to repeat the question for people online, so I think the question from Eamon, hopefully I summarise it correctly, Eamon, is the target audience just for farmers, and is there other opportunities in other sectors and stuff like that?
Yeah, so as I'm keep repeating the same word, customization. So here, as I said, as per the industry use, we can customize the hardware and the software accordingly. And 40 kgs is it's a good payload, like for the drone. So you can use in other industry as well. For example, like instead of using pesticides, we have developed the attachment. We have developed the universal attachment. So you can attach the hose, and it will use in the renewable energy for cleaning the windmill blades. So it can be used like that. It can be used as the cargo for limited cargo from one point to another point, because it has lifting capabilities. So it's completely it's open for all the industries. It's not just agriculture industry that we are targeting. So basically, we are currently working in different countries, partnering with different organizations to go in the different industry as well. So that's the plan for us. So it can be used in any other industry as well as agriculture.
So I suppose the question just, and we got Alessandro. So the question would be, if you follow on to that, like if you look at, say, what Bobby Healy is doing with Mana Drone, like what's the competitive advantage you have compared? And I know you know Bobby anyway.
Yeah. So Mana Drone it's on the smaller scale. As I said, there's our drone is 3 by 2 meter, 1 hour flight time that we have currently. And other thing, lifting capability, 40 kgs is a big payload. So currently we are targeting B2B instead of B2C.
Okay.
So that's we can say it's a completely different sector, because our category it's we can say like medium large drone. If we talk about in the European Aviation Safety Agency particular terms, so we are currently in the medium large drone section, where the Mana Drone is on the smaller drone section. So that's where we are standing right now.
Great. Thanks, Daria. Alessandra?
European Innovation Council. I would like to know the technology readiness level of your system.
So the question for Alexandra from the European Innovation Council is he'd like to know the technology readiness level, scale from 1 to 10 of the TRL level.
So currently we are around like 8.5, because the most of the thing that we are using right now is custom build. So we are building everything in house. So we can say 8.5.
So for people that might know what technology readiness level is, kind of expand on what 8.5 actually means. It's ready for usage.
Yeah.
It's
So
commercial.
yeah. So currently, as I said, that in few months we're gonna start doing our pilot programs here in Ireland. We have a few farmers. We have a livestock farmer up in Donegal. We have a potato farmer in Wexford, Wicklow. So we're gonna do pilot programs for them. We are just waiting for the approval from Irish Aviation. We already filed for the approval. They are basically checking all the technical things and the manuals and all the stuff. So yeah, in few months we will be promoting the demo, and then we will be launching drone as a service. So hopefully by end of the year, we'll be in the market. Yeah.
Excellent, excellent. So I think we have another question. Okay. So Mohammed, do you want to unmute Mohammed and ask your question to Daria?
Yeah. Am I audible?
Yeah, we can hear you. Yeah, go for it.
Yeah, Daria, first of all, thank you for the wonderful presentation. I have one query that since you said that this is an autonomous processing of data or the machine learning models, so can you just tell me that either the processing of the data which is collected by the sensors, is it being processed on the board? Does it capable to process a lot of or a huge data which is collected like from the cameras or the sensors? And second question is, like, have you considered the security or the cyber security perspective of using the drone? Like, there are so many like open source software defined radio jammers. If someone is going to use those jammers in order to like stop the functionality of drones, then have you considered these kind of cybersecurity perspective in the drones? Yeah, thank you so much.
Yeah, that's a wonderful question. So as I said that we have developed our own software, and we are storing data in our cloud. So the drone will be processing the data in the real time. So basically, we will get the data process in the real time with the help of cloud-based system that we have developed. As well as if we talk about the security, we have currently implemented two security channels. One is primary, and the secondary one. So we have alert system for the particular remote pilot or the operators. If any kind of breaching in the primary system, then the remote pilot or the operator is gonna get instant alert and can take control of the particular drone. And we have encrypted security system already implemented. So that will be very less chance that and also like it's just not, the drone is just not operated by the radio frequency RFD. It will be operated with the 4G and 5G. And currently I can say the secret that we are also working on the SATCOM right now. We are doing R&D for the SATCOM communication as well. So in the few coming months, we will be also ready to go up with the SATCOM communication. So that the security perspective, we thought about it, and we are confident that we have pretty much covered it, and we are confident about the security.
Great. Thanks, Dario. Anybody else? Any questions in the audience? Yeah, go ahead.
Yeah, so currently, me and Simon currently working on the business model right now. As I said that we will be first launching our pilot programs. So with the help of the pilot programs, we will be able to gather the data, as well as we will be seeing the results. And after that, we will come out like the perfect and the precise particular business model. That currently we are making business model according to the market and like the different market around the world. But if we talk about the Ireland, so we would like to go first with the pilot programs, and then we will be launching our particular business model or the revenue and all the stuff. So yeah, definitely, when we will be launching this thing, we'll be definitely particularly publish our revenue models and all of the stuff, that how we're going to proceed as a drone as a service. But currently we have thought about the two process, renting the drone and the leasing the drone. So the renting model is going to be like our operator is going to come to the particular places and do the particular operation for the farmers or the any other industry, and we will charge according to our or the particular area base. And for the leasing one, we will you can basically lease the drone and you can operate it by yourself.
Great, thanks, Daria. Any final questions? No, all's good. Okay, great. Thanks, Dario. Really appreciate it. We just have to take 1 minute pause. I think there's just swapping audio, but Luca, you're here anyway. Ready to go in a minute anyway, yeah? I'll just take guidance from Hero and Fanula there when we're ready to go. So we're almost there, guys. We're on bang on schedule. So we just have one more presentation for Luca, and then we'll have Patricia Scanlon, our AI ambassador, joining us at 5:30 to talk about developments in AI in Ireland. So yeah, well on track.
Company based in Dublin. Big or small, we serve them all. We are focused on computer vision and machine learning. So I was thinking that, today is the last talk. Actually, there's one extra talk, but it's late. It's a summer school, so maybe, I don't know, maybe this is a lab session, okay? Which means that I will need your help because we have 3 problems to solve. There are 3 computer vision problems. So my first question is, how many machine learning engineers in the room or connected? Raise your hand. 2 machine learning engineers, 3. Excellent. How many computer vision enthusiasts or experts? I take all. 1. Fantastic. We're going to have a lot of fun. So just to start, the clicker should cooperate with me. Yeah, okay, GemAI, I already said what we do. So what is computer vision? So computer vision, for the ones that are not familiar, is AI for images and videos, okay? You see there a nice image with apples, while computer vision is, among other things, detecting stuff in an image like that. Reduced to, really the basics are in this slide. You have a camera takes an image is composed by pixels. Each pixel has 3 values. You take these 3 values, you have 3 matrices, you're in business, okay? And then you can do whatever you like with it. You can classify cats. You can localize and classify cats, which is detection. You can extend to multiple objects of multiple categories. You can segment them. So these are the typical problems you can solve with computer vision. Now, obviously, there are many different applicative domains. The sky's the limit. This is the typical video surveillance kind of Big Brother use case. Then there is the old school concealed weapon detection through X-rays, logo detection, document analysis. This is pretty much, you know, the usual suspects when it comes to computer vision. Now, computer vision, we're going to look at computer vision in agriculture and energy, and we're going to use 3 examples, real world examples from customers of ours. I'm not going to mention the name, but yeah, I think what matters is how computer vision gets very tricky in vertical farming, biomass plants optimization, and pest control. We're going to also look at obviously the upsides, but yeah, as I mentioned, it's a lab session, which means that I'm going to throw you into the problem, and probably, you know, there are going to be some questions that you might get, some others where you will need my help. So you will pretend to be my machine learning engineers. Okay, so I've got like 20 machine learning engineers. I have 6 at home. Here much more. So pretty sure that within the next 20 minutes we can cover these all. We'll see. So first thing, so what we need to do for one of the leading vertical farming companies in the world is to optimize their yield. Anyone familiar with what vertical farming is and you know what they do? Growing. Yeah, excellent answer. So when you're growing, obviously you want to grow and you want to optimize yield, because at the end of the month, at the end of the day, the higher the yield, the more the profits, right? So when you are growing in a vertical farming, you're typically using actuators or robots, like this robot arm here. So what this robot does is it transplants needles. Okay, so it takes these plants pre-made from this tray, and with a pretty complicated movement, it just puts them into these holes here. Simple. All right. Now, what is the problem? There's always the but, and the but is that these things tend to break, okay, or to bend. So if one of these things bend, you're not going to be able to pick up the plant, right? Now, one batch every 45 seconds, okay, and which means that if one of those things fail, you're going to get a 88.3% loss in yield. This thing is loading every 45 seconds. So if you're not fast enough and reactive enough in detecting these kind of failures, you lose a lot of money. Okay, so I need to solve this problem with you with a computer vision system. Okay, so what do? We want an F1 of 99.9%. Anyone familiar with F1? It's just a measure of accuracy. So we want to know that we're not going to miss any of them. Okay, and we also want to have perfect. So we don't want any false positives. So we don't want to stop the production line, for a misdetection. Okay, so we just want to stop when we have one bad example. Okay, so how do we do it? Can I go back here? Yes. So how do we do it? Do you have any ideas, any intuition on how you can design a computer vision system that detects these kind of failures? And I accept everything. So first of all, what kind of problem is this? The answers: detection, classification, or localization. A, B, or C.
A and B.
So I heard detection and classification. I think, we certainly need to stop this machine, right? Okay, so I would say that this is, the most complicated problem is localization, because you have to localize, you have to detect and localize. All right, but at the end of the day, we want to just stop. So in theory, we could interpret this as a detection problem, which is simpler to solve because we just say, shit, something is going wrong, stop everything. So I think this is a detection problem. Now, given the nature of the problem, do you have any intuition or ideas on how to have a detector that detects this kind of situations? Visual detector.
You said that as examples with empty prongs like that one or places along the line, use that training data to generalize.
I like that. I like it very much. So what we would do is we would acquire a lot of this data, okay, and then we will train an AI that detects these kind of scenarios. Now, what's your name?
Mike.
Mike. There's an extra complication, okay, and as usual, I'm the guy who always brings the bad news to my machine learning engineers. I bring you a bad news, motion blur. So it's not the same nice image as before. More bad news, ghosting. Okay, ghosting is another effect. Another one, these cameras get dirty. Guess what? Somebody has to clean them. And if they don't clean it, we have all these weird effects. Okay, so how do we make our detection more robust? Because if we use an off-the-shelf technique that just randomly, just generically learns from the appearance, we might miss these examples of bad. Say it again.
Question of comparison of good and bad.
Good and bad, yes. So I give you 3 ways forward. Number 1, we detect these needles. Number 2, we detect the whole image, or number 3, we detect the arm. So 1, the single needle, 2, the whole image, and 3, the arm. Which one do you think it's? Which one? Who thinks that detecting the arm is a good idea? Okay, who thinks that detecting the needle is a good idea? Okay, the needle wins. Unfortunately, that's the wrong answer. Okay, so the right answer is this. The right answer is the simplest answer. So you want to focus on the most prominent and more stable signal that you have, which is the whole arm. And then it's just a convolution, which is very frustrating for a machine learning guy, because I was thinking maybe we can develop enough nice detector, deep learning, something very strong and very robust. Instead, I learned it probably 25 years ago, and it's just a comparison, okay? Smart comparison. So this was a very interesting learning for me, because I spent probably 2 hours to implement this method, and I could have spent, like, a machine learning engineer of mine could have, gone around and spent like a couple of weeks just fiddling with YOLO and with detectors, etc. So instead, with this beautiful solution, we get probably 96% accuracy. So the first lesson learned is in here. Always make simplifying assumptions. So do you have an intuition about my simplifying assumption? It's written here. So we have always the same actuator. It always has 12, they call it end effectors. We match the whole shebang. Does it make sense? Okay, so this is the first point that I would like to make. The second point that I would like to make is that, as you can see here, with computer vision, especially in agriculture and farming and maybe even energy, the devil is in the edge cases, meaning that this beautiful thing that we call computer vision works until it doesn't. Okay, and it doesn't because of situations, because we are monitoring living things that change all the time, appearance changes all the time, or situation change. So let's move forward. As Mike was saying, then we're going to take a bunch of images. We're going to label these images as good and bad. Okay, green, good. Red, bad. And then we're going to train a detector. Okay, convolutional neural network for the ones who like machine learning. These are the results, 100%. Problem solved. Okay, note that it works until it doesn't. Because when we are taking into account image aberrations, performance go to 90%, 92%. It's like saying, okay, so I have an IT, I'm in front of an ATM. I go to an ATM like 10 times a year. And once a year, the ATM doesn't give me money. So what would you think about that bank? Not that great, the technology, but this is the kind of tools that we are left with. Okay, so when we are trying to sell computer vision and more broadly speaking, machine learning, we are trying to sell something that once out of 10 does not work. And that's why my job is so interesting, actually. Okay, so this was the first problem. We have solved it. Thank you very much for your help. Shall we go to the next one? Or you have questions about this?
No problem. You guys like.
Yeah? Yeah, so the convolution gives you a weight, you threshold that weight, and then when you have a value above that threshold that you set, happy days, you have a match, go for it. Okay? Simple. And simple is good because it's cheaper. Your margin are high. Okay, this one is a completely different kettle of fish. We're going to Argentina now. Okay? So there is this big beast. This is a biomass plant. Are you familiar with biomass plants? Okay. So I think there is one or two in Ireland. Biomass plants are, these big beasts. They have a lot of fuel. Okay. They take this fuel, they ship it, and then they throw them into a boiler. Actually, there is a boiler and there is what they call in Spanish caldera. I don't know how to translate in English, but I think you got the point. So there should be a video here. Okay, so this is the input of the caldera. So this thing is throwing chips, wood chips into the heating room. Okay, what we need to do is to maximize output, which means that we have to help them making more money. And this is pretty much bottom line. It's always the case, right? So what they are paying us and myself too is to create buttons. You put that button and you make more money. That's the promise of AI. That's the real benefit. So to make more money in this business, you have to take this graph, which gives you the output megawatt hours across time. You have a nominal value, which is never attained, and you have to bring them to that nominal value, okay? And our problem, the problem we're going to solve together is adding 1 million in revenue per year by transitioning from 37.7 to 38.7 megawatt hours. So we have to add 1 megawatt hour to their current output. Does it make sense? Mm-hmm. So how do we do it? Okay. Second, please. Okay, we have 3 options. And I don't know why this is not, yeah, now they're all go. So we need to place cameras. And we want to place cameras in a way, in the right way. The way that helps us determining analytics about these wood chips. Is the wood chip small? Is it big? Okay. Is it wood chip of a specific type? So my question for you is, which one, where would you put the camera? You're machine learning, sorry, computer vision experts. You have done it many times. It's a plant in Argentina, so you don't have control. You know that you have 3 options, 3 horses. Where do you put your money? A, B, or C? Okay, so let's try A. Who is voting for A? Nobody. Who is voting for B? 3. Who is voting for C? I think is C or B. Now, any intuition on why you voted for C? I mean, you picked your horse. Anyone would like to share why picked C?
I said C on the assumption that this is sequential from left to right, so you've got input on A, you've got processing on B, and you've got output on C. And
Yeah, so that could be the case. Any other intuitions on why A would be better than C? I don't know.
Sorry, it appears to be slower.
Slower, okay, it's slower. All right. Any other ideas on, what makes a viewpoint better than another? There's more data. Okay. Liam, okay. Anything else? So when I'm looking at these kind of videos, the first thing that I do is I look at the viewpoint. Okay. So from a viewpoint perspective, A is great. Okay, because I have a vertical view. I can see exactly what's going on. I can see the spread. I can also see very nicely lit wood, which will make my classification probably better. Here, it's going very fast, but I might have a way to stop it, okay, with appropriate hardware and maybe with some lights. This one, I don't like it at all. And I don't like it because there are too many moving parts and my detector could get very confused. Okay, so I think I would go with A. All right. Now that we solved this hairy problem, here's the next one. Okay. We have different types of wood, and different types of wood combined with different levels of humidity can give you a different output. We need to separate the pine from the eucalyptus. Okay, so I'm going to tell you already that I think this is pine, okay, and this is eucalyptus, right? So the question for you is, what are the visual attributes that make you think that this is one and the other? So can you mention at least one visual feature that discriminates between these two classes? Exactly, color. Okay, so what is going to be very important in my setup, like camera setup? Light. Pardon? Light. Exactly. So what do I have to tell the clients to do? I have to tell them, look, also buy some very good lighting setup, because if you have the incorrect lighting, this feature, forget about it. Okay. And this is not even, I don't know, I mean, it's non-technical, there are no formulas, but you fail on this, and there is a 6-digit bill that goes to the bin. Okay, so 6-digit investment that goes to the bin. So this is very important. Second, I'm going to give you now 3 different features. Okay, and you have to solve this problem for me. You have to tell me which one is the feature that impacts the most on the output. Okay, it can be humidity. It could be wood chip size. It could be the species of wood that you're using in your caldera. So who thinks wood chip species is the most important? Raise your hand.
You give a second for the online.
Yes. Okay. How about the size? So you're judging whether or not the size has a big impact on output. So is that creating a big fire, small fire? At the end of the day. 1, 2. Okay. And how about humidity? 1%. Okay, humidity, I think it wins, right? It's very hard to burn something that is wet. That makes a lot of sense. So I think that's the right answer. So we should rank these features in this way. Humidity first, wood chip size second, species third, shape fourth. Okay. Now, I'm going to speed up a little bit, but this is what we said: high predictive power for humidity, and then all the rest. Can you tell me what is going to be the most complicated feature to extract now? And this is hard, I know it. One is from an external sensor, the other from the images. Any ideas on which one is going to be the most complicated, so least technically feasible? From image, humidity, okay. Shape. The shape. Any other ideas? You can throw that, no problem. Okay, no more ideas. This is it, more or less. So the easiest thing is humidity in principle. We will see in a minute why. Wood chip species, very complicated. So my job is to take these two things and calculate an ROI and tell to the client, look, this is hard. The potential return is medium low, forget about it. This is high, let's go for it. And this is what I did. Result, this. This is a correlation between humidity and output. What do you think about this graph intuitively? Is it good or bad? Any intuition on what to look for when you're looking at a correlation? What would you like to see? Is it good? Is it bad?
Sweet spot. Humidity needs to be in a band.
It looks to me like a big potato or something like a mashed potato. So it doesn't look good at all. Like I would expect a nice, line, nice correlation. The correlation here does not really exist. So I'm like, oh no, what's going on here? And then turns out that the sensor was faulty. So this is the reality of AI. Despite all the claims, despite all the generality, then you end up with something that does not work and a shouting client because something in the middle is wrong. Okay, so the lesson learned here, there are two lessons learned. Number one, ROI first. I call them endorphins later. So I've got like a lot of PhD students and a lot of machine learning engineers that just go for the sexiest feature, okay, or for the most challenging approach, while it's all about the ROI, okay? And my job is to keep them, focused on the right ones. The second lesson learned, no, I'm sorry. I'm really sorry, guys. I'm messing it up badly. The second lesson learned is that you really have to be careful about the statement that you're making, especially if your sensor is not a sensor that you have in front of you, okay? So let's move forward, and I'm sorry about the back and forth. So we ended up writing a code for this pipeline. The pipeline starts with the image. The image gets segmented. You remember the cat with the outline? Same principle, but here we're segmenting small chunks of wood. And then for each wood chip, we are analyzing the type of wood, the area, the shape. Make sense? We're almost done. So this is an example of the segmentation. So this is the original image, and this is the segmented image. Again, you're machine learning engineers. How do you feel about these results? Pardon?
Disaster.
Okay. Can you elaborate more?
Oh, it's very hard to recognize the pieces.
I think it's not a disaster, but it's not great in the sense that you only get this. It only gets the big ones, okay, and you totally ignore the rest, which might introduce something in your measurements, right? Do you know what that something is, or how do we call it in machine learning jargon?
And recognition.
Yeah. Or
Overfishing?
maybe this is the result of the overfitting, but if we were only considering the big ones, it's a little bit like saying we did a great we did a great market research study. We only took Italians in Dublin. Is that a good research?
No.
Because?
Bias.
Exactly, bias, right? So we would bias our analysis because we're only focusing on the big ones, okay? Focusing only on Italians. Not great.
Another comment? Moshi?
Moshi factor. Yeah, I need a little bit more to answer on that. Okay, so let's wrap up because it's already late. I think you want to do another one, and this is actually a one question. We can stop here and wrap up.
No, do the last one.
Are you sure?
Yeah.
Okay. Early pest detection. Now we are in South Africa, and we have a client, crazy client, who wants to equip their farmers, and some are real farmers, some others are people that are working in remote geographies with an iPhone app or a smartphone app that automatically recognizes blight. I didn't know what blight was. Probably do you know? You know. So blight is this nasty disease that affects potatoes, and you can recognize it because the leaves are getting browner, and ultimately, I think the plant rots. So my question is again: let's assume that I show you healthy leaves, not so healthy leaves, and very unhealthy leaves. Can you predict F1? So can you predict the accuracy of a a computer vision system that will classify these images into 3 categories? So in other words, can you tell me if it's A, B, or C? So if F1 or accuracy is within 0 and 50, 85 or 99, or 50 to 85. These are the kind of questions that if you're a machine learning engineer are not going to learn by watching YouTube tutorials, which are great, by the way, if you want to implement stuff, etc. So, but when you're delivering AI, a client brings you these kind of images and use case, and you need to come up with an estimate so that you can, quote, you can understand where are you going with this project. Now, I'm going to show you again the images. I have them here. Yes. Okay, so you have an understanding of very good, not so good, very bad, and you're going to tell me what is going to be the performance of a computer vision algorithm solving this problem only by looking at these images. Do you have any guess? And so who votes for A? Raise your hand. 1. B? 5. C? 4. Liam, you voted twice.
No.
Okay.
All of you.
Anyone tells me why?
Good images were quite distinct, but the other two classes were hard to be distinguished by eye, and they had similar colors.
That's a pretty good analysis. Any other thoughts? Any other things that we should look at to ground our prediction?
If you only care about color, if you only care about good, then color.
Color is good. I would say that first of all, is this an easy problem or a difficult problem from your perspective? Again, machine learning engineers, come on. It's difficult. Other perspectives, easy, difficult. Sample size too small. Well, I didn't disclose. These are just examples. That's a good point, but I didn't disclose how big is the data set. Any other? I mean, there is one very easy to spot because it's common to everybody. It is a constrained environment. What do they all have in common? Come on, there is something that is common to everybody. Background, exactly, and that could make a lot of difference, right? So this is not in the wild. This is, you know, there's nice light, there is a nice background. All these leaves are carefully. So this is an easy problem from the let's say constrained environment point of view. Now let's look at these leaves. You were mentioning color. Is or can? Because I see a lot of green here, right? I see also some yellow, but yeah, there's a lot more yellow here than there, right? We all agree to that, correct? Let's look at the shape. Is the shape affected by this bloody blight? What do you think? Slightly. I feel like it's, yeah, slightly. There are deformations. These are neat and elongated and coherent. Some others, like especially in this category, they have this bad pattern. So you want to know final result? Edges, yeah. Final result is 92%. Good stuff. So this is an easy problem, as an easy solution. 92%, would you buy it?
Depends.
Why?
Depends what 8% saves you.
Exactly. So it once every 10 times is wrong. So the real question, to answer the question, would I buy it? You should take into account the impact of that mistake over 10 examples. So how much money I'm going to lose, you know, as a consequence of that mistake. Exactly. So it's a multifaceted answer. I feel that we should wrap up. Final remarks. So the first thing that I would like to say is thank you. Okay, this was great. And by the way, second thing that I would like to tell you is that our business grows by referral. 20-second, marketing message, if you allow me, which means that if you feel like there is somebody you know that wants to have a chat about AI, you connect with me now or later. You let me know, and we have this referral program. We would take care of you guys. But let's get back to business. So what did we learn today? And I hope that these are interesting learnings, even if you're not in the business of computer vision. The devil is in the edge cases, in computer vision, but also in machine learning. Always make simplifying assumption. In life, this is also true, I think. Size the problem. If a problem is not big enough, don't even start thinking about it, because AI and computer vision is an expensive beast. Look around for ancillary benefits. We didn't talk too much about it. Let's forget about it for the moment. But yes, maybe when you're optimizing for revenue, it's great if you are adding extra dollars in the pocket of your client, but maybe there is another benefit that goes with those extra bucks. ROI first, we discussed about it. And then this is the hardest part. And this is where, typically people hire people like me. You have to think as an algorithm, as we did for the blight. So you have to think as an algorithm would think, so you're able to predict the performance. And that's it. Thank you so much. If you want to talk to us, in one click, you can book an AI clinic where we have these 30 minutes sessions together. Thank you.
Well, Luca, you're fantastic on time and everything like that. I really appreciate it. And look, I know it's coming towards the end of the day, but you definitely made it very interactive. And I suppose what I always like about any of the conversations we've ever had is you make me feel really comfortable around AI because you talk about it in plain English and it makes it very simple. So well done. I know it's very interactive sessions. So I'm not sure if there's any questions, but if there is, we can take any question from anybody online. or from here before we move to Dr. Patricia Scanlon to close out the day one? Everyone's happy enough? Okay, well,
thank you.
good. Thanks a million. Oh, hold on, there's a question. You thought you were running away. You actually just nabbed it. So do you want to unmute and come on with the question? We've hand up there.
Yeah. Hi. My name is Artem. Yeah. So really quick question. Because we've been talking about environmental sustainable goals, and in your experience, Luca, how do companies like this, I think, return of investment versus just sustainable goals and social aspects? Do you see company have resource to think about it, or they're still focused on?
Well, I would hope that in the future it's not revenue, it's sustainability, what we're optimizing for. At the moment, it could be the case that revenue is number one and sustainability is the very big ancillary benefit.
Okay, thank you.
Thank you.
Great. Okay, so just to close out today's session, we're doing something similar to what we did last year. So we're delighted to have, I think, Dr. Patricia Scanlon, who's our AI ambassador here in Ireland, and also the founder and CEO of Soapbox Labs, who's joined us from Dublin. Can you hear us okay, Patricia?
I can, yeah.
Great. Listen, great to have you, and thanks for taking the time. I know you're probably one of the most busiest people in Ireland at the moment with where AI is at and things like that. So thanks for taking 15 or 20 minutes to talk to us. So look, I just have a couple of, everyone's had PowerPoint all day, Patricia, so we've had death by PowerPoint, and as a former Microsoft employee, I can say that or whatever. So we don't want to have any more slides. We really just want to keep this as a kind of a Q&A and keep it interactive. But for anybody here who doesn't know who you are, maybe if you want to just give a quick overview of what being the AI ambassador for Ireland actually means, and also maybe a kind of a quick overview of your day job with Soapbox Labs.
Yeah, happy to. I'll start with Soapbox actually, and then I'm the founder and executive chair of Soapbox Labs. We build voice AI for children. One of the things we did before the term was even coined was we did take an ethical approach to building our AI because it was for children, and our initial use case, our initial vertical, was in the education market. And two things we wanted to do. We wanted to make sure it was data privacy secure. It works for all kids, regardless of accents and dialects, and that definitely, is what we're looking at now when we come to the EU AI Act and bias mitigation in AI. But very much the idea is the way we think about our children is really how we should think about all people in society. But we tend to be a lot more sensitive about our kids in terms of data and how the AI performs. But really, that is an ethical approach to AI. So when the government released Ireland's AI strategy a couple of years ago, one of the items in there was the appointment of an AI ambassador to Ireland. And very much Ireland's approach has been to take an ethical or trustworthy or responsible, there's lots of different terms you can use for it, AI approach. That's very in line with what the EU are looking at as well. So I kind of thought it was a good fit. I reckoned I had the experience from, my own background. I'm 25 years in the space of AI now. I have a PhD in speech recognition. I built a company that was focused on AI. It didn't kill us. It was tough to do it, to take that approach, but it very much is possible. And sometimes people like to think about or push the narrative that, regulation kills innovation, and I very much wanted to tell our story about how ethical AI is very achievable. It needs to be done with intent, but it's very much now a USP in the market that people trust us. And commercially, it's not just a moral, ethical thing to do. It's also, advantageous commercially. And if you can tell both those stories and get people to understand the value of it, that really helps.
Great. No, thanks, Patricia. I suppose, look, the focus of this year's AI Summer School, I know when you were here last year, we were looking at artificial intelligence supporting the tourism industry. Today and tomorrow is all about artificial intelligence supporting sustainability. So today we've been talking a lot about AI for sustainable farming and hearing a lot about how, you know, soil and crops and animals and how AI can support there. And then tomorrow, where the focus kind of goes to more around AI for sustainable cities, you know, carbon footprint. Like from your own kind of vision of AI and sustainability, how do you see AI supporting the whole sustainability agenda?
Yeah, it's definitely, when I talk about AI, it's definitely, you know, we talk about the risks of AI, but when you actually really go, okay, there's massive benefits here. I talk a lot about climate and how, you know, the better modeling, the better AI we have that can ingest vast amounts of data and produce really accurate models of prediction really help in forming policy. To be honest, often when you can explain to people the economic ramifications of not solving for climate, you know, because some people, they need that kick to be able to understand why they need to do this. It's not just, you know, the peril of a human suffering. It's like, you know, buildings and roads and the damage and all this, and then suddenly people start listening, and unfortunately the dollar speaks louder sometimes, you know. But those types of modeling and prediction really help form the agenda when it comes to regulation, policy, and roadmaps. And I think AI has the better the modeling gets, the better we can help convince the decision makers to take action, right? So I've always been big, you know, and there's a great company in the UK that I've known for a long time that does this type of prediction. They help the insurance industry understand, and they're showing big impact on that, being able to demonstrate on the climate, you know, modeling and prediction. But also there's huge benefits in terms of energy and resource management. So you talk about smart cities, you know, being able to manage resource, optimizing energy consumption, you know, in homes and industry, reducing waste where possible. Even in the case of looking at predictive maintenance, use AI, something I worked on a long time ago when I was in Bell Labs on predictive maintenance. You can actually save a lot of energy by making sure your machines are running efficiently. You know, there's lots of things that AI can help in that. You know, the idea is replacement early before catastrophic failure. But also in biodiversity, when we're talking about being able to make the case for the ideas that there's endangered species, there's, like, you know, deforestation, there's, you know, when there's problems arising in a biodiversity sense, when we actually start to implement mitigations and we start actually implementing things to solve it, demonstrating what's working, you can use AI to do that too. And then again, you're making the case a lot stronger than manually having to gather this information, which is traditionally how things have been done. You know, a big agenda on sustainability as well, I think, is worth talking about, is the fact that there is an impact on the LLMs, and I'm sure people have mentioned that today, or they will tomorrow, that, you know, the language models, the Open AI, the Google Bard, the Amazon one, the Microsoft one, all these different ones, they actually are consuming vast quantities of energy. I don't know if you've heard this, but it's like hundreds of millions to run these every couple of months. Like, so, you know, that's the cost you can imagine the extent of the energy that they're consuming. So there's a big effort gone in now to try and reduce this, you know, to narrow the focus of these, talk about making them smaller, lighter, less consumption, even to the point where they may actually work on device, on the edge, as opposed to in the cloud, where the costs are high. So there's that balance. There's a lot AI can do, but the AI we're seeing at the moment is actually causing problems, and there needs to be a lot of research and regulation stuff to be able to help, because we can't sustain it, I mean, into the future. So a lot of innovation needs to happen in order to reduce the energy consumption, so we don't end up having an even worse effect on the environment than we're dealing with already.
No, that's a great point. And actually, our keynote speaker earlier on, Colleen Jacobson, from the US, is ex-Stanford University. She talked about sustainable AI for sustainability and sustainable AI, and talked about that, and we had the guys from IBM as well talking earlier on, talking about how they're trying to reduce that as well. So 100% agree with you. You mentioned earlier on there about the AI Act, or I think you call it the EI Act. Yeah. Could you talk to us a little bit about what that is? I mean, we've heard a lot about it in the news and stuff like that. So, and what the impact is on, you know, the companies maybe that are here at the AI Summer School, or even on the citizens and stuff like that. What I'm imagining it's around ethics and privacy and stuff like that, but maybe tell us a little bit more about what it covers.
Yeah, so this has been in the works for years. I mean, we're very fortunate in the fact that it was in the works. This type of legislation, regulation doesn't come out very easy. It does take years. So the fact that we're on the tail end of that is really good. It covers the idea of looking at the end use case. So is the end use case high risk, medium risk, or low risk, or forbidden, right? And that's really important because if it's medium risk or low risk, it doesn't impact a human's life, the trajectory of a human life. So if you think about what high risk might be, then it's anything around finance, making decisions in education, in employment, in medical and healthcare and stuff like that. So if you imagine using AI in any of those senses, making a decision, making an assessment, making a prediction, making a hire or a medical decision, can affect the rest of somebody's life, like financial decisions, whether who gets the loan, who doesn't. So they're all deemed high risk use cases, and as a result, they're going to face tougher regulation. Again, nothing impossible. It's all very achievable, but it's just the fact that if you are bringing out AI that's going to be implemented in those risks, you have to do more to prove around bias and accuracy and security. And again, nothing that, like, if you think about the finance sector, fintech is very highly regulated, as is medical field, healthcare, employment, all those things. They are already regulated, and they're already, we all have a lot of legal experts in those spaces. So again, this is just going to be, it's not a surprise that we're going to have to do this, because there's lots of examples of AI gone wrong over the past couple of years where people did implement some kind of automation or AI, making decisions at scale, making an error impacting hundreds of thousands of people or millions, and there's consequences to that. So again, now that the regulation is almost caught up, the technology, not quite, but it always lags. There are going to be certain regulations that's going to have to be implemented. And what the EU AI Act has been around for a couple of years, and up until last year, never mentioned generative AI, foundation models, any of this new technology that we've all seen released since OpenAI last Q4 last year. So the EU have gone and added language only in the last couple of months to kind of bring them into the fold and have them somewhat regulated. Hugely controversial and some, huge amounts of lobbying, as you can imagine. But important because we've all seen the impact, and we all know the next year is going to be, we're going to see a massive impact from those LLMs and in everyday life, in every aspect of life, across industries, companies, home life, personal life, everything. So, we need to account when those technologies have an impact in high-risk use cases.
Right. Now, my second last question before I open it up to the audience is, I know you're kind of working through the process at the moment of putting together the AI Citizen Assembly, and I think the deadline was last week or a few weeks back for applications. I mean, what's the whole kind of ambition or objective behind the AI Citizen Assembly, and what do you hope to kind of achieve from it?
Yeah, sure. So it's an AI expert advisory council, right? So it's AI experts giving advice, cross-government advice on a range of topics. So it will be, we're looking, what we're doing is, and it closed just earlier this week. We had hundreds of applications and it's been fantastic. But the idea is to cover people from academia, industry, legal, ethics, civil society, economy, workers. So to make sure there's representation of those people, but it's expert, right? So, the government already have the civil servants, they have the policymakers, they have all those experts. What was missing was as the technology is moving at a blistering pace right now, when new technologies come on, new controversies come up because of the technology, that government and people have a place to come to ask advice for it to be explained. What is the technical pros and cons of this? What are the concerns here? What are they talking about? What is, not having that kind of expertise. And again, we're not replacing policymakers or decision makers. It's an advisory council. We can't force it down anybody's throat. It's just going to be advice. So it's going to be a push-pull. In some respects, it will be aspects of government or civil service coming to us with requests to help explain things or give advice. And on the other half will be things that we will be notifying about, something alerting, something new coming down the line, some new concern, you know, and just being able to help and be very much that sounding board on it, but with experts from a range. And it's not going to be dominated by industry, it's not going to be dominated by anybody, and that's really key. And everybody on the council will be independent, they'll be representing themselves, they won't be representing any body that they work for.
Okay, great. And look, my final question, and then I will open it up, is it's probably getting you more to kind of put on your crystal ball and look into the future, because I know, like, when you were here last year, I don't think you could have imagined how AI would have kind of exploded across, you know, the last while. And like, even from my own perspective, I worked, as you know, for 4 years in the Adaptation and Trinity College Dublin, and none of my family had a clue what I was doing, because when I explained artificial intelligence, they just never got it. And now I go home and they're experts, because they're all into ChatGPT. And when I was explaining about going to the AI summer school is, oh, that's all about ChatGPT. So what do you think is going to happen in the next 12 months? Like, if we had you back here, hopefully you will be back in 12 months time. What do you see kind of happening over the next 12 months with AI, and where do you think it's kind of going to go?
I think what we're going to see is, I think from last year, I mean, again, the interesting thing is that, you know, generative AI, foundation models, it's not like nobody ever thought about that. We just didn't think it was going to come as fast as it did. And I think that's really key. What I'm seeing is hundreds, if not thousands, of groups, be them startups, research groups, groups within multinationals, are working and building on top of foundation models. And when real innovation happens, it tends to happen at the kind of the crossroads of people with very unique experiences meeting very powerful technology and very niche products of this, very niche use cases being implemented. I think it's going to be a case of almost, but certainly in the next 6 months, and it's already happened. It's very difficult. There's so much activity. It's kind of like the App Store circa 2014. It's not like there wasn't amazing products there, but it was finding them, sifting through the rubbish. Again, it was discoverability. There is a huge amount. I mean, I think we talk a lot today about OpenAI and Google and all that. We may not be talking about them in 12 months. We may be talking about somebody else. We may be talking about people coming out of the woodwork that we haven't thought about. You know, Facebook or Meta released Llama 2, you know, these open source LLMs. They may not be as accurate as OpenAI's LLM, their foundation models, but maybe it doesn't matter, because what happens with foundation models is you're fine tuning for a use case, typically, right? We can all use ChatGPT and it's very general. But what a lot of the innovation is happening now is that people are taking the GPT models, fine tuning them to be used in particular use cases, and that's going to be extremely powerful. So people are going to be using proprietary knowledge, proprietary data, fine tuning and building these real innovations with or without the help of OpenAI. They could be on the back of these open source models. There's a lot of other models in the world. I think there's a lot. It's going to be, the challenge will be those who can rise above the fray and the noise. And for us to be able to discover the truly useful stuff, because right now there has already been billions of dollars thrown at innovation in the space. A lot of it's vaporware. For investors, the challenge will be ascertaining what actually truly has a moat and what is just a bit of a wrapper on someone else's work. So I think in another year, you're going to see a huge amount of people being burnt, investors, by investment in making the wrong calls. There's a lot of subtleties. You get somebody very good at selling. There's going to be, you know, it's very hard to sift through what's real and what's not. So I think the next year is going to be, if you're sick of AI in your newsfeed, like, you know, just wait. It's not going away anytime soon.
Okay, great. Listen, thanks, Patricia. I just want to open it up. Any questions online, please put them in the chat window. We've got about 5 minutes. Anybody, any questions in the audience that want to ask Patricia? Any challenging questions? You must have a question, Hugh, have you? You know Hugh Reynolds, Patricia. Have you ever heard of Hugh Reynolds?
I think so. I know the name.
In the spot.
Oh, yeah. There's no such thing as a free lunch, been here all day. No, when he's okay. Yeah, go ahead.
Around financial services, we're very strong in fintech, right? And you said that we're actually very good with the cluster that expertise we've developed. You see that as an opportunity for Ireland. You're actually develop explainable AI, ethical AI, financial services, with high risk, right? Will require more investment.
Sorry, the question, just so everyone online get it as well, is there a big opportunity around explainable AI and some other AIs within the fintech sector? Yes, yeah.
Oh, 100%. I mean, one of the big problems with a lot of these LLMs is they're not explainable. The way they've been built, it's not explainable. So, I think this is going to be a bit of a challenge for, if you're using, so it depends what you're using it for. In the fintech sector, if you're using it to make a decision about who gets the loan, are you using AI or are you building on these LLMs or something like that? So I think everybody's trying to distinguish that you won't be allowed to use anything that will actually make decisions. Now, is it scanning documents? I mean, or is it creating productivity and efficiencies within the fintech sector, or is it actually making decisions? That's where the difference will fall. If it's making decisions, mortgage applications, loan applications, credit scoring, whatever like that, and the computer says no, is not going to be sufficient. So I think that's going to be a massive challenge. There's a huge amount of research going on at the moment on new approaches. So the approach that was being used for the GPT models and ChatGPT's transformer models, they're fairly brute force small. They don't actually spit out why the decision was made, and a lot of it's black box stuff. That's not going to fly. Maybe they can be used to make smaller decisions, and then on a whole, it's going to be more of an if then else kind of thing that's actually going to be able to make it explainable. It's almost like the problem would have to be broken down into smaller components to be able to make it explainable. I think that's going to be a challenge, but I actually do think that's an opportunity for a lot of innovation within that space, is to make decisions within high-risk use case explainable. And there's a lot of work going on, a huge amount of research, but what we're looking at now with the ChatGPT and stuff like that, they're not built for that. So a lot of the people who are just throwing that behind decision making in fintech, I don't think that's going to wash. But again, they got 2 years to figure it out, right? Because the regulation isn't actually going to have any teeth until it's done.
Right, thanks, Patricia. Yeah, Hugh has a question this time around. Yeah.
Took me about a minute to come up with a question. One with the I guess the writers and actors strike that's going on. And one of their kind of concerns is the training data that's used and the ownership of that training data. So you went and scraped all the legal documents in the world, and now you're a lawyer. But what happened? How do you see that playing out? Is there a case where we're going to have to try and put that genie back into the bottle, and you have to somehow try and explain where the training data came from?
Yeah, that's actually in the EU AI Act. They actually changed the wording recently to include that, and this is massive. I think there's class action lawsuits going on in the US. I know Sarah Silverman, the comedian, she's actually bringing one of the voices, very vocal people on bringing, because apparently she asked it to write a summary of her book and it did. So it has her book in there. So she's there going, well, there's proof that you've actually, and Getty Images can show on the generative AI, stability AI ones that, they have a warped logo there. So their images have been used. So what the EU AI Act said something about, it's like a disclosure about, it's like that model card idea that you're going to have to start disclosing what IP is in there. The EU AI Act hasn't said what you do with that information, because that's still a fairly grey area. But if they're forced to disclose what's there, then that's opportunity for people to take further action against them. There's also the AI Liability Act that goes along with the EU AI Act that puts the onus on the companies, not on the person who feels they were harmed by it. But when it comes to the IP stuff, I think it's very much still up in the air. Not really sure how to address it. The way the big tech guys are doing it now, that they're saying they can't disclose it because it's competitive. You know, so they're saying, oh no, we can't tell you what's in our model. That's part of our secret sauce. But clearly, once they do have to do that, then they're opening themselves up to lawsuits. That's not going to go away very easily. So there's going to be a lot of money and power thrown in on both sides of that. I don't see the EU weighing in on it at the moment, on what to do. But the ideas, I mean, there's some great ideas kicking around going, well, maybe like a royalty fee, you know. You play a song on the radio, you make you pay a royalty fee to the artist, to the musician. You know, is that practical on a global scale? Like, you know, if you have actually copyrighted something, trademarked something, you know, you've actually gone to the legal steps to protect your intellectual property, then maybe there's a case there that you have some right to build it. But should going into the future, should these companies just solely profit from all this IP? And, you know, I think there's other challenges as well. Who owns the IP that's created? If you prompt image generation or text generation, who owns it? Is it the person who wrote the prompt? Is it the people who own the models? They haven't really figured that bit out either. Who owns the result of the prompting? So that's open too. I think it's interesting. You know, then the people whose IP, you know, was in there, if Getty Images logo is all distorted in the final result, do they part own that? Like, you know, so I think this is. I remember doing my engineering degree in it was the mid-90s, and I remember the professor saying something like, you know, law always likes technology. But I think this is like lagging on a massive scale, because it's not even obvious how we resolve this, like, you know, at all. And I don't think, honestly, I really think it's still wide open. I'd love to hear another opinion, but I've not heard any clear way of resolution at the moment.
Okay, great. Listen, thanks, Patricia. No, I think we finished it there on a good note. So, look, we're conscious of time, and I suppose, Patricia, first of all, I just want to say, like, thanks for coming back on here again this year. I mean, I know you're incredibly busy driving the AI agenda, and I think you do an amazing job as AI ambassador for Ireland. So thanks for all that, and thanks for joining us here as well. So big round of applause. Thank you.
Thanks, guys.
We're right on 6 o'clock. We promised you we'd be out here at 6. So again, look, just want to say thanks for today. Hopefully you got some good insights into artificial intelligence, sustainable agriculture. You know, hopefully you saw a really good mix of academic and applied speakers over the last 5 hours. I know we got through a lot and stuff like that. And look, thank you for being here. Thanks to everyone who presented some really good insights. So we'll start again tomorrow. We'll have free breakfast outside in the collab space from 8:30 onwards. So anybody who wants to get here early, an opportunity to get free breakfast. We're going to start in at 9 o'clock with Joan Mulville. Anybody who knows Joan, she's ball of fun, ball of laughs, and she'll build loads of energy to get us going at 9 o'clock tomorrow morning. And then we've some fantastic presenters. Professor Vinnie Cahill will be presenting for Trinity College Dublin. Professor Brian Caulfield. We have the guys from Maynooth University with Microsoft talking about the Terrain AI project. And we have a lot of really good applied sessions as well, like Eamon Galvin from Known Carbon, the guys in Fexco, and we'll have some international speakers from France as well. So I'll pack the agenda tomorrow from 9 o'clock to 1 o'clock, and we'll try and get you guys out by 1. And then there'll be a free lunch if anybody can stay until 1 o'clock tomorrow. Okay. So listen again, thanks for your time today. And hopefully we'll see everyone around 8:30 tomorrow morning. And thanks to everybody who's been online as well. Hopefully you had a good experience and you got some insights, and we'll see you back in the morning as well. Thank you.